Okay, good morning, folks, for joining for this Cyber Resilience and Operational Dominance and Critical Infrastructure Summit. This summit is jointly hosted by UND and Idaho National Lab, and we have a packed two-day agenda for you. This is a digital event. Thank you for being here with us. We have over 100 folks going to join these 2 days workshop. I hope you can make use of the best of your time. And just for a quick overview about this is hosted by Center for Cybersecurity Research. UND is a Carnegie R1 classification school, also NSA designated CAE-R. We have a number of ongoing DOE projects. We have programs in cybersecurity engineering, cybersecurity, and we have weekly webinars. If you want to interested to tune in and subscribe to our weekly webinars. And this event is also co-sponsored by IEEE Red River Valley section and IEEE PES and PALS chapter. With that said, I'll invite Dr. Virginia Wright from INL to say a few words. Ginger, are you there?
Sorry, I was going on mute. It's been multiple years of this and still forget to hit that mute button. Good morning, colleagues and friends. I am excited to start 2 days of a deep conversation about cyber resilience and operational dominance, two things that are necessary for us to future-proof the critical services that we deliver. We will move from policy to practice, from academic research to operations in the conversations we'll have, and we will include sectors from water, energy, and other. We share the responsibility to understand how resilience in our operations benefits the people that depend on the services we provide. We hope that in these 2 days, you'll get ideas and approaches, ways of thinking about the challenges that approach us and mitigations for them that haven't occurred before. I'd like to highlight for the Idaho National Laboratory, we will be presenting on Thursday at lunchtime, some training that is available to you at no cost, and some virtual, some in person. And then just to cap off the training idea, on Thursday afternoon, we will provide a workshop on cyber-informed engineering to help you begin to adapt these methodologies to enhance your resilience. But first, we have some exciting speakers, including Jamie Sample, who is going to do our keynote presentation. Before we start that, just a brief view of the day in front of you today. Take a look at the talks and certainly itemize the ones that you would like to attend. We hope you can make all of them. During the lunch period, there will be a break. So our Q&A may expand over the lunch period, and feel free to stay if that's possible, or move as your day requires. On day 2, we begin with a plenary talk and a significant panel discussing how utility resilience is changing in view of policy, regulation, and technology. So make sure you highlight that on your calendar. And then a number of presentations, again, including a couple of training ones. So I would like to introduce everyone to Jamie Sample. Jamie is a managing director at Deloitte, where he focuses on serving the energy, resources, and industrial sector. He is an accomplished senior executive with over 25 years of experience, where his extensive professional background is defined by significant program transformations, strategic leadership, shaping national policies and programs, and board-level advisory, drawn from his experience in Fortune 500 companies, government agencies, and Big Four consulting. Before joining Deloitte, Jamie held key leadership positions at various prominent energy companies and other Big Four firms. He most recently served as the Vice President and Chief Security Officer at Xcel Energy, where he led the Enterprise Security and Emergency Management Organization, which was responsible for ensuring the security and resilience of the company's operational and business assets. He also served as the NERC Senior Manager and the executive responsible for leading the company's COVID-19 response and return to work strategies. Jamie's other positions include serving as the Chief Information Security Officer at Pacific Gas and Electric, Tennessee Valley Authority, and California Independent System Operator. As a principal at Ernst & Young, where he served as the America's Energy, Security, and Operational Technology Leader, he worked alongside critical infrastructure owners and operators to help safeguard the nation's most vital operations. He also served in the United States Navy, thank you for your service, as a cryptologic technician. We happened upon Jamie's post that talked about the importance of operational dominance and offered some key techniques to achieve this goal. So I will turn things over to Jamie, who will talk about that and help you build your operational dominance. Jamie?
Great. Thank you, Virginia. So good morning, everyone. I want to first thank UND, INL, and the NSF for putting this together and hosting this conversation. I'm excited and honored to be here among such other distinguished speakers and attendees. As Virginia said, through my experience, I started thinking about what is operational dominance and how we need to be thinking about fighting, the enemy, regardless if it's asymmetric, adversaries or weather, anything that's coming against us as a threat. And, we work a lot with operational excellence to drive cost savings and efficiencies out. And it made me really start thinking about how everything is coming to our battlefield, how everything's coming to us. We're not going to it. And that there's no reason that we can't start anticipating, avoiding, and adapting through an operational dominance lens. So that's kind of the genesis that came, that kind of drove the operational dominance concept. So, let's get started with the ground truth. I think we can all agree U.S. critical infrastructure is surviving today, not necessarily thriving when it comes to this area. Most organizations are stuck in a reactive or passive mode, accepting the current circumstances and only focusing on bouncing back from the last disruption. But in today's world, the threats move at relentless speeds, from cyber and physical attacks to extreme weathers, to civil unrest and supply chain disruptions. We've seen all of those. So mere survival and response to those isn't enough anymore. All hazards mindset is essential. And if you aren't thinking about outpacing the hazard and how to get ahead of the hazard, you're falling behind. This isn't about sidestepping risk. It's about capturing an opportunity by design. Operations that shift from a passive defense to operational dominance architecture, architected environments where hazards are proactively avoided. And when hazards do hit, they're prepared to not just endure, but to thrive, because they set the playing field on their terms and to their advantage. You'll hear over the next 2 days not only how to detect these, but how to survive and how to architect those outcomes by stopping playing defense and start shaping your future on your terms. When you think about the heart of operational dominance, there's really 4 key drivers. The paper I wrote has kind of 8 steps, but it really aggregates up into 4 major drivers. One is own the arena, and that means design to your advantage. You don't wait for luck or hope or think things are good enough. And too many organizations mistake proactive preparation for siloed defense, meaning each functions are building controls around industry standards or known hazards, focused only on their vertical or their slice of the business. But when hazard strikes, as we know, they don't respect those boundaries within organizations. This narrows the lens and leads to gaps, overlaps, and blind spots, ultimately making organizations victims of circumstances. And the circumstance is developing resiliency through silos. Leaders must intentionally and deliberately take action to break free from this fragmented mindset. The real shift is designing systems, processes, and teams that see the entire playing field. They're anticipating how hazards move across functions and driving coordinated adaptive responses. Operational dominance isn't only about bridging silos. It's about breaking them and engineering holistic advantage so that the hazard never gets to set the rules. And the hazard being whatever the threat is that we're facing. So, kind of break this down into a typical failure, right? Cyber team deploys rigorous controls against unauthorized access. They put in all this infrastructure security, access, intrusion prevention. They see the perimeter as the battleground. The network team is working, designing networks for speed, uptime, internal collaboration without close alignment with the cyber or application teams. They might create a flat network with fewer boundaries because it speeds up time and makes lateral movement easier for anyone who gets inside. Application team is focused on functionality and rapid deployment. Sometimes, skips or undervest in critical application level controls like secure coding, input validation, or logging through the process. So in this case, the consequences, while they're not, there's nothing intentional there, each group's doing and focusing on its area and doing what it thinks is right in each of those areas. But the consequence is a threat actor breaches one weak spot, configuration in the app or a stolen credential. And instead of hitting a brick wall, they find that the network is flat, allowing them to make lateral movement or pivot across the network, exploit unpatched or legacy systems very easily, and bypassing controls that weren't architected at a multi-layer. So this, in that case, this organization has not achieved operational dominance. They've handed their organization to the adversary. And again, they didn't do it through intention. They just did it through the normal course of business and not thinking about how does architecture of the network systems testing impact each other. The second major area is around intimate knowledge. Knowledge, as we know, is power, and you have to know yourself and know your hazard. Victory starts with radical self-awareness and hazard mastery. We always hear you must know your assets, your dependencies, and vulnerabilities, but that's only half of the equation. You also need a deep insight to how hazards operate and which specific threats truly matter to your business. So, let's take another classic scenario. You discover a critical application running on an insecure protocol. Threat intelligence verifies a motive, capability, and capable adversary who targets exactly this weakness. The winning move would be unified cross-functional defense, right? This means mitigation isn't a security team silo act. The application team has to apply the patches, the network teams have to put in the indicators of compromise to watch for it. And so it's a team effort around that. And this gets back to, the whole concept of not only knowing your hazard, but to know yourself, know your enemy, right? If you don't know your environment, you can't defend it against an enemy. And if you don't know your environment, you can't also put in mitigating controls because we can't always fix our environment, meaning that there's architectural design that's going to foundationally or fundamentally be there that you can't change. So you're going to have to put in your layers to say, okay, how do we protect against that? The next major area is around full spectrum visibility. Seeing everything and missing nothing, right? Blind spots are fatal, and you can't fight what you can't see. So fragmented data, silo teams kill the speed and precision, giving the hazard a free pass. One of the big things around operational dominance is around getting that full end-to-end view so you can correlate. So let's take, for example, today we've got Grid Operations Center, we've got Security Operations Center, we got the NOC, we got the Physical Security Operations Center. Each one of the centers are doing a great job. They are monitoring their areas of responsibility, and they're seeing their part of the playing field. However, they're not connecting the dots. So for example, you will have, gas operations gets a gas pressurization change and says, oh, that's just par for the course. They're going along their way. 8 hours, 10 hours later, still hasn't changed. Send somebody out and they discover that the door has been kicked in and somebody's turned the valve. Well, if you go back and do the investigation and look, well, there was a door contact alarm that went off 6 hours before gas pressurization alarm, things like that. So you can, without getting these alerts to a central location, not taking the responsibility away from those operation centers for real-time response and operations, but bringing that in for correlation and understanding if there's any events that are connected, slows down the speed and gives the adversary a head start. So that's the focus around full spectrum visibility. And then the last major area is around empowering decisions at the edge. And this is get actionable intelligence where it matters, right? So when you keep up with the intelligence and decision, or when you keep intelligence and decision power bottled up, you not only kill the speed, you kill the ability for the front line to make smart moves. So no matter how good your centralized insights are, how well your threat intel teams are, or how well your operation monitoring teams are, if they're the only ones that has that information, the contacts, context around it, and it's not getting out to the front line, you are handicapped, because the front line is who sees a lot of the stuff at the very beginning of it, right? So the big thing here is to flip the script on it, is making sure that you're getting the threat intel out. And also a part of empowering decision at the edge is exercises. We hear a lot about, we do a once a year exercise or whatever. That's not enough to really get that muscle memory. So one of the big things around empowering decision at the edge is not only getting the intelligence out, it's getting the muscle memory. Practice like you play. Many of us remember Firewatch and battle stations if you were in the military, that we would exercise that all the time, no matter what, right? And so the idea was just to get that muscle memory. So when you hear the alarm, you know exactly what you do and how to do it, versus thinking, well, gosh, I got to go read that manual, or I got to go read the playbook. Is if you're having to go back and read the playbooks, then your response isn't very well. So as you go through and look at these four major areas, is there really a set of intentional moves that you really have to do to make it a reality? One is you have to put a name on it. You have to make operational dominance a top-tier business function directly accountable to leadership. If you think about it again, how do you cut across those silos? It's not just happenstance. It doesn't, the groups are really busy, focused on their areas. They're not going to say, oh, well, I need to go talk to networking, or I need to go talk to operations, or I need to go talk about field response teams. They're going to be like focused on their area. So you've got to be intentional and put somebody in a leadership role that is going to drive those cross boundary discussions and coordination. The second major implementation is around engineer for shock. Is you have to architect the system to operate under duress. Build agility, resiliency, backups, manual overrides from the start. Cyber-informed engineering that you heard Victoria mention, that you'll hear more about, is all about that. Is how from the very beginning do you say, we're going to engineer for shock right out the gate. This third major implementation is outlearn the threat. Is you have to train your leaders, your field support folks, on what the real world crisis is, or what the real world threat is. And they've got to know what they're dealing with as well as they know their own system. If they don't, the more they understand what the threat is, how the threat acts, the better they can make on the ground real world decisions to counter those or to respond to those. We talked about unify the picture, breaking down those silos, getting all of those alerts from those independent operation centers and correlating those to define, to find patterns or sequences or things that are going on that impact each other. So you can respond faster. The whole thing here is about speed and context. Speed is great, but if you don't have context, you're going to make the wrong decision. So the faster you can get to the context and the event correlation, the better you can be at defending against the threat. Rehearse like it's real. Again, stress the teams with realistic crisis drills at every level. I had a chief operating officer that when I was at the California ISO that said, I want to come in one day and hit the emergency shutdown button for our primary operations center and not miss a beat. That our secondary site picks it up and we don't even see a hiccup in the system. It took us about 4 years to get to the point where we could simulate immediate loss of power without any operational impact going from primary to secondary. But without that insight and vision that he had, saying that this is this is how we need to operate, we would have never gotten there. And we rehearsed it, and I actually talked to one of my colleagues there, and he says, no, we still do it monthly. Once a month, we do we rehearse like it's real, we shut down, back up, and do everything. So it's important to rehearse like it's real. Prioritize what matters. We've talked about this, is you have to restore by mission priorities. If you think about it right now, if you had a total system failure at your organization, what would you bring up first across your mission? We have a lot of important things that goes on across a utility, but if you were forced to force rank, what would you bring up first? What would that be? Right? Would it be emergency operations so you can get field response going? Would it be electric operations, gas operations? Would it be liquidity and finance? What would it be? So it's better to go through, have those conversations on what would you bring up in what sequence, so you can prioritize what matters when it happens and be proactive at it. And at that point, you can protect and create not generic playbooks. You can create playbooks specific to those mission priorities. The seventh item is to build a reflexive culture. This is to drive trust, intent, and adaptability down to the edge, making it a reflex, not a procedure. This goes back into enabling that front line. And then number 8 is adapt like you mean it, meaning turn every incident and drill into systemic learning and improvement, right? There shouldn't be anything that happens in the industry or at your organizations that you're not analyzing, looking, learning from that, reapplying it, and adjusting your environment to make sure you're adaptive. So operational dominance, actually, kind of closing out here so we can get to any questions or comments, is operational dominance comes from radical self-awareness, total visibility, and empowered action at every level. When you know your assets, understand the threat, connect the dots across functions, and trust your people at the edge to act, you transform risk into opportunity and chaos into competitive advantage. The reality is the sophistication and velocity of hazards are at an all-time high and increasing. The old playbook of siloed response and top-down control is a liability. Organizations that win, those that thrive under pressure, are built on systems where knowledge and authority are distributed, visibility is seamless, and every player is dialed in and ready to execute. So ask yourself as you go through this, are you equipping your people, systems, and leadership to see everything, act quickly, and outmaneuver risk? Or are you letting legacy structures slow your response and dilute your defensive? The choice isn't about protecting what you have. It's about building an organization that's fit to win every day in the face of whatever comes next. So with that, I think you're going to, as Virginia said, if you look at the agenda for the next 2 days, I think you're going to hear some amazing case studies, techniques to address each of the areas that we just talked about and what makes up operational dominance. And it's, again, as I was preparing for this and was talking to the team and preparing, operational dominance is not a new concept. There's nothing here and that you've heard that is like, wow, I've never heard that before, right? It's all about, though, putting it together into a comprehensive concept and then make it a focus, right? And steal from all the great stuff we've already done and really operationalize it and breaking those silos down. So with that, I'm going to turn it back over to Virginia to open up for questions or whatever's next.
Thank you, Jamie. I will invite everyone here. Please put your questions in the chat. I see one that came in. There is a PowerPoint presentation that is the bio for Jamie's sample. So if you see that on your screen, you are connected. Otherwise, there are not slides for this particular presentation, but there will be for other ones. And Jamie, for you, one of my favorite stories about operational resilience comes from a company called Netflix, who, when they had to stop shipping those little red envelopes into our mailbox, recognized that the future of their company was in someone else's hands. And they began to explore how they would deal with frailty and came up with the chaos monkey. I wondered if you had heard of that and how we can promote Chaos Monkey for the energy sector.
It's yes. And gosh, I was trying to think about, you caught me on that one, right? To look at it is, I think one of the things we can do around Chaos Monkey is
so Chaos Monkey, I was reminded of that when you talked about the executive who wanted to turn the button off and was willing to take a risk that had existential consequences in order to build up the strength to fight a real challenge.
Yeah. And what I was kind of pausing on, right? One of the challenges we get is in our industry around the Chaos Monkey is, our systems are real time all the time. We don't have the capability to do that, right? I mean, I've heard for years, oh, you can't vulnerability scan OT. Well, we do now, right? It took time and effort to be able to understand what and how you can scan it and be able to understand vulnerabilities, right? So it took effort, right? It wasn't just point and click and go. And it took a coordinated effort, right? As many people know that's rolled out vulnerability management scanning into OT, knows it's just not a security function, right? You have to work with field engineers. You've got to work with the vendors. You've got to come up with alternatives that might not be off-the-shelf alternatives, right? To figure out how to do it, but you figure it out. So it's an intentional act. So I think on the Chaos Monkey component, around randomly shutting down instances in the production environment is, I think that with digital twin and the technologies we're seeing today, we can simulate that and still preserve the operational reliability of our systems. You might not be able to, again, don't let perfect be the enemy of good. You might not be able to do everything at one time, but if you're able to, even a part of your environment, do digital twinning on it, which there's commercial off-the-shelf products to do that now, just do that part right now, right? That's better than nothing, because you can take that and spread it across other areas, right? So you don't have to be perfect around that. So that's kind of where my pause was around that on that and the scenarios. But I think the technology that we have today does not give us an excuse that we had in previous years, right? We've got the technology, we've got the resources, we've got the national labs that can simulate stuff for us. So the resources are there. It's just taking the time and effort, and again, putting somebody in charge to think about it. I'm always a big believer of the body, of the head on the body. Right. I go to a lot of places and I see a lot of arms and legs and bodies, but then it's like, where's the head? Right. And so I think once you put the head on the body, you can effectively do chaos monkey. And I think that there's no reason you can't do it.
I think that's a great answer. I have another question for you from the chat, from Marija Ilic, and please let me know if I did not get your name correct. How does one connect across silos and respect CEII constraints? And if you can explain CEII for those who may not be organized under that constraint, that would be helpful.
Yeah, exactly. Thank you. And thank you for the question. CEII is critical infrastructure information. So it's a categorization of information associated with critical infrastructure. Connecting the dots across the silos, it's a planning game. You have to sit down and understand what your interdependencies are. And once you understand your systems and understand that, I think you can connect the dots, right? So I think connecting the dots is a planning process, right? More than anything. It's understanding what is priority. Like I said, I remember doing an exercise with the executives and sitting down and doing exactly what I talked about during the keynote was, if we had a catastrophic failure and everything went down, what would we bring up first? I can tell you there's not one executive in the room that had the same answer. We had everything like, oh, we had to bring up HR and payroll. Oh, we have to bring up this. We have to bring up that. It took about 3 sessions to get down to what we called 17. We had 17. I've worked with other companies that's had 13, others that has 20 mission critical processes. Once they identified like what would we bring up, and remember, you cannot bring up everything at the same time from a mission standpoint. You just don't have enough resources. So you have to force rank. So first of all, having the discipline of what would I bring up first, and then say you can't have 1A, 1B, 1C, and then 2A, 2B. You have to have 1, 2, 3, 4. By forcing that discussion, it gets everybody to really understand what's important. And then you can then start saying, okay, if my number one mission critical process I need to bring up is emergency management communications because I need to make safe, then you say, okay, what are the components of emergency management do that? And you can start mapping your assets to those processes. And so all of a sudden at the end of the day, you might go from 10,000 assets across your environment to 700 that are critical. And that planning session around understanding what's critical allows you to start connecting those dots. As respect to CEII, I personally feel that it's been a while in the industry since we really looked at information protection. Out in 9/11, we put in a lot of classifications and all of that, and I think with the current technology, it's probably a good opportunity for us as an industry to say, how do we classify and all that? Because, we're seeing where, I'll give you an example. We've got developers that are in the process now with renewables that they can't get access to the information, and how do we get on background checks, or how do we get them cleared and all of that? So I do think we have a information sharing challenge at times around CEII, and it's unintentional around it. And I do think it's an opportunity for us to, as an industry, to go back and say, how do we want to do information management in today's society and going forward, right? Because it's only getting more interdependent and more complex, and so we've got to figure that out better. Right now, it's a it's patience and working with what you got for information sharing.
Thank you. Our next question is how operational resilience can be optimized with the aging of the utility, especially for the energy sector.
Yeah. Going back to being deliberate, right? I remember working when I was leading emergency management, working with my peers, and they'd say, okay, we've got tech debt or we've got, legacy systems. And how do we bring that up as a risk, right? So that we can start bubbling it up and getting attention around it and start moving it. So I think in the aging of the utility is you've got to have a mechanism that raises it up on your risk radar so that it gets funded and becomes priority, right? I often see organizations chasing the next shiny object and not thinking about what they currently have. And you go down and you talk to an operator and they're like, oh yeah, this system's 30 years old and we buy products off of eBay to keep it up and running and all of that. And then you go up to the risk office, up to like chief risk officer and all that and see, is that being bubbled up? And it's not. It's not getting that visibility. So I think the way that that how it can be optimized is really look and say, do we have a process that bubbles up the most risky stuff across our environment and doesn't keep it down, sheltered or out of visibility? Because I've not met any executive in the utility sector that I've personally ran across that once you've identified a risk that has an operational or safety issue, that they don't take it seriously and they don't fund for it. What I find most of the time is they're not aware of it because there's processes or things that don't allow it to get bubbled up. So I think for this question around how it can be optimized is risk management has to drive transparency down into operations. And what we see a lot of times, and I don't mean this in any negative way, we see a lot of risk management programs are really good at financial risk, right? Because if you look at a lot of the risk management and chief risk officers and all that, and I'm not dinging any of them or anything, this is just reality. Most of your chief risk officers are the CFO, or they're in the CFO organization. So they're really good. They're quants. They understand the financial risk management. When you go and you start talking about operational risk, it's a survey that goes out once a year to the operations teams to write it down, and it bubbles up to a risk register. So I think we have to strengthen operational risk management across the industry to drive to get to the answers to the question you ask around that.
Thank you. Great answer. And yes, we've seen a lot of fragmented risk management that is not operationally informed.
No, not at all.
Our last question is, do we have or can we standardize the whole cyber resilience approach through operational dominance domain around a small spine of recognized OT or ICS standards? So which standards would you build upon to do this process, or is it outside of the current standard set?
Oh, wow. The way I think about standards, right, is they are North Stars that are one size kind of fits all across, and it's up to each organization to take the best out of the standards, right? And I would love to be able to say, here's a single playbook or a single standard, and if you do that, you're great across the board. Reality is all of our environments are very dynamic. Each standard has its strengths and weaknesses, right? You got the ISO standards, the IEEE standards, you've got OWASP standards, you got NERC CIP standards. All of them are strong in their own right. And trying to centralize those, you would take that power away. So I think you have to look, it's like a toolbox. When you're a handyman or handy person and you go and you open your toolbox, it's got a flathead, a Phillips, a hammer, a drill, so on tools, right? There's not one tool that fits everything you're going to do. And I think of the standards the same way. You've got to put those standards in your toolbox, and you leverage those standards based off of your situations around that. One of the things, I'm cyber by background, right? I came up through the cyber ranks and really embraced operations when I got to the California ISO, because I was really interested in why are we even doing cyber? What's the why, why are we doing it? What do we do? Just, I would go out on the operations floor and just spend hours out there watching them do operations, because it was just amazing to me of them running that, right? And what I started realizing through my career, especially when I had emergency management, is that cyber's kind of created separate playbooks and all of that. We've got to break that down, right? Cyber is a part of emergency management. Cyber is a part of risk management. Cyber is a part of operations and quality control. If you look at a lot of the controls for cyber, they're just quality issues, right? It's a quality control problem. So anybody that's done TQM or quality management, cyber is the same thing. Is you put a control in, is it working or not, right? So I think we've got a lot of operational concepts that we can really embrace and drive back in and make cyber integrated in, versus saying, hey, it's its own special thing, because it's not, and I'm coming as a cyber person, and I'm not special or anything like that. I've as a cyber person, I've got to figure out how to leverage those concepts that are in operations and all of that, and say, this is just an expansion of those, right? It's not, and in a lot of cases, it's the same thing. It just looks different. So I would say challenge yourself. There's not a single standard. Put all the standards in your toolbox. Use the bits and pieces out of each one that fits the environment or situation you're in, and then reuse a lot of the operational practices that we have, right? Because they're there and they're good, and it can accelerate. Like I said, incident response for cybersecurity is no different than emergency management, right?
Thank you, Jay. We have 2 more minutes. We have one last question here, if you don't mind. That in large-scale critical infrastructure environments where legacy SCADA and modern IoT-based control system coexist, how do you recommend architecting a zero-trust security model that balances deterministic communication requirements of OT networks with dynamic authentication mechanisms?
Yep.
Typically? Yeah.
Yeah. I'm going to go back to like standards, our North Star, zero trust, multi-layers of defense, all of that are just buzzwords, right, around that. I think when you think about zero trust, what you're really trying to get to, and you have to think about what you're really trying to get to with zero trust. What you're trying to get to with zero trust is saying, hey, we want affirmation that, people are connecting to me or who they are, or that the system can self-protect itself. So when I think about zero trust, one of the things I go back to is back to the vendors, right? Is as owner operators and implementers, we can't necessarily design the stuff. We might be able to implement it in a way that creates an air gap or creates some trust components. It really comes back from engineering at the very beginning from the vendors. If the vendors are not thinking about interoperability and zero trust, when you get the product, you're going to be just implementing what you got, right? So I really think on the zero trust model, we've got to push back up into manufacturing and the vendors, and drive inner discussions between them, right? Because like you said, they're all doing it separately. And I think that we can only implement what's given to us the best that we can and operate it the best that we can. It's got to start with design. So I think working with the national labs, working with the vendors, doing, us sticking together as an industry on on pushing requirements back in, and pushing the vendors to build zero trust and authentication and verification into their products has to be a zero-sum game. They have to do it, right? And so the more we vendors might not like this, but I'm like, it starts with the vendor. The vendor has to develop it in order to, in a way that we can implement it into zero trust. We can't just go out and magically make the environment zero trust. It has to be designed that way.
Thank you, Jamie. I think we're running out of time, so it's been a pleasure to have you for this morning with us. It's a great honor to have you. Thank you again. In the interest of time, we're going to proceed to the next next session. Thank you, Jamie. Can we show the next slide, please? Okay, the next talk is about solutions and challenges facing small to medium businesses to maintain cybersecurity standards. With us, we have Mike Prickett, Chief Strategy Officer, MCG Energy Solutions, and Mike is, and also Jayson Nelson as well from MCG. Let me read Mike's bio. Mike is a Chief Strategy Officer at MCG, where he drives corporate strategy, cybersecurity initiatives, and FedRAMP compliance efforts to ensure secure cloud-based energy solutions. With over 30 years of experience in the energy and technology industries, Mike is a strategic leader dedicated to advancing innovation, operational excellence, and digital transformation across the energy sector. Also, Jayson is Chief Information Security Officer for MCG Energy Solutions. In this role, he develops and implements strategies to enhance data security, privacy, and protection, driving the company's cybersecurity initiatives, including the FedRAMP compliance. Jayson also brings over 20 years of experience in infrastructure security and data privacy. He holds key industry credentials, certified information system security professional from ISEAI and certified information security manager from ISEAI. It's a great pleasure to have Jayson and Mike. The floor is yours.
Thank you very much. We're really happy to be here and to join this and appreciate the opportunity. I first want to take a second to thank Jamie for his opening presentation. He really nailed so many things on the head. I've not heard a presentation quite as good as that got right to the heart of the matters. And when we thought about what are we going to present here, we kind of had two ideas on the table, and one was to go the route that Jamie did, and one was to go the route that we're going to. And I'm glad that we didn't go the route that Jamie did, because we would not have done it as well as he did. And I hope that our presentation here today is very complimentary, but I think really everything that Jamie hit on there is so succinct. And he's thrown a little bit of a curveball in my presentation, because I want to touch on some of the things he did in the context of real life. So I am Mike Prickett. I am the co-founder and Chief Strategy Officer of MCG Energy Solutions. We are a 30-year-old software company that provides operating systems to predominantly wholesale power industry, but we also touch on natural gas, because our clients use a lot of gas, obviously, to run their power plants, and we deal in some liquid fuels as well. The company provides 14 products, which we provide from our private cloud. Just a little overview on the products. We provide a number of real-time products, including an interchange scheduling platform, which is used by balancing authorities to balance their footprint of the grid in real time from the transmission side. We have a power marketing platform that does a number of things, including real-time scheduling and trading, as well as providing the ability to interact with the ISOs for bidding generation in the real time and day ahead, all of the settlement of the market. So again, another mission critical platform. We have a meter management system that has become very much an operating system. It used to be more of a back office function, but in today's world has become an operating system by classification. It manages time series data, which is predominantly in the form of meters, and allows for submission of those meter values to the ISOs for purposes of calculating L&P prices. It does counterparty checkouts. It does the calculation of billing determinants. It does jurisdictional load calculations. It has a massive number of use cases. Then we have a billing platform that bills virtually any kind of contract for wholesale power. That could be an open access transmission tariff. That could be legacy integrated power and transmission contracts. Really anything you need to bill in a wholesale context, it does. Then we have another platform that is a quant platform. It does market risk for forward positions in energy. That could be power, liquid fuels, really any energy commodity. Does mark-to-market VAR, Monte Carlo VAR, all that fun quant stuff. The other portion of that platform is credit risk management. So it is managing the counterparty credit risk profiles per the contracts you have with your counterparties. We have another platform that is I refer to as sort of a three-legged stool. It is one part outage management, which has become a very, very critical operating system in the power world because of intermittent resources. And the ability to communicate those in a very timely fashion to both the ISOs and your adjacent parties. It also has a health, safety, and environmental component to it. So it does all the permit to work, lockout, tagout, OSHA-related things. And that is also becoming a very, very important part of the world. Then lastly, it does operator logging. It does operator logging for virtually any industry, but in the power world, it's obviously used in the power plants and substations, and also very important in today's world. And we have a market price data platform. We aggregate all of the prices from all of the ISOs into a platform that supports either consumption of that data through a series of APIs or through a UI that lets you do analytics. That platform is the power price source for the Bloomberg terminal today. So it is largely deemed the best source for power prices in the world today. Within our quant platform, we also support gas scheduling. So that's the nominations and then actually talking to the pipelines. We have a jurisdictional load system. That is what it sounds like. It's for the purpose of an entity that has loads in multiple states and needs to report those to the PUCs annually. It does all those jurisdictional load calculations and reporting. Lastly, we have a platform we call HDS, which is Hosted Data Services. And what that is we will aggregate all of the data from any of the other products I just described into a singular database broken down by schema, so that our customers can interact with their operating systems as if it were a local database to them without creating any risk to the operating systems themselves, because some of these platforms are so critical to operations that we can't just have everybody in the organization interacting with it from a development standpoint. So that platform is to isolate the operating systems and still provide full access to the customer's critical data. So going back to Jamie's conversation, I want to talk about how we go about things a little bit in terms of dealing with the silos and how we prioritize things. So when we look at ourselves, and in working with our federal clients through the FedRAMP process, we quickly came to the realization that our number one priority is uptime. From a security perspective, our data is not high criticality. Grid data is virtually all historical, right? Things are happening in real time, and it instantly becomes historical and does not present an inherent risk per se to anyone or the organization. So our number one priority is uptime. And Jamie's points about the silos that fly in the face of the mission are very, very real. So in our world, we are very fortunate to not have to deal with a lot of the things that Jamie talked about. So as he talked about, hey, if we're down and we have to restore the business, the operating environment, what's our priority? And in our world, we are purpose built. So all of these products that I described to you are built on the identical software architecture, which I will not go into today, and we're really not allowed to per FedRAMP, but they're all built on the identical software architecture. And so we are able to build and operate our private cloud as though we have one and only one application. And I've always said, if I had to run this set of applications in a corporate environment whereby I had all those important things like HR and all these other platforms to consider in my attempts to make a highly secure environment, I don't know what that would even look like. It would be so challenging to account for all of the nuances of all of those systems. So the biggest way that we deal with that is that we have an infrastructure that is built to run one and only one application architecture. By doing that, we have massively simplified what it is we have to deal with. So in our attempts to secure one application, we secure all of them. And so Jamie's point there is really an important one. You have to try to simplify everything you can. The other point is the silos, organizational silos. And we deal with that by essentially breaking it into two groups. We have our infrastructure team. They are responsible for managing all 3 data center sites. They are responsible for the technical side of the FedRAMP program. And then Jayson is responsible, he's part of that infrastructure team. He is responsible for the administration side of that, which is interacting with DOE, the agencies, reporting to the C-suite within the company. So we have the infrastructure team that is all things data center level, if you will. Then we have the application teams, and the application teams are responsible for keeping the applications themselves compliant with whatever the latest, greatest is in FedRAMP. And then through the Kanban process, which is continuous monitoring, which necessitates that we patch the entire environment every single month, the application team is responsible for ensuring that every single application is tested to the latest, greatest patch sets. So our approach to the silos that Jamie described and the complexity of the environment is to literally have a purpose-built environment that has to do one and only one thing, and that is run a series of applications that have an identical architecture. How we deal with the silos is we keep it to 2 groups. And those 2 groups are very much in sync. There are regular meetings about FedRAMP compliance between those 2 groups, but it isn't 8 groups or whatever it is, as Jamie described in some cases. So that is our approach. The other thing I would like to touch on that Jamie brought up is the vendors. So the vendors create tremendous challenges. So a little anecdote around that. As we were progressing towards the final state of our initial FedRAMP audit, there is a component of it known as FIPS. And of course, that's a very important part of FedRAMP. But So FedRAMP was moving to the next level of FIPS, and none of our core vendors were to that standard, and we didn't have any of them that were going to get there within, correct me if I'm wrong, Jayson, but about 2 years. So we were there at the final judgment day with none of our core vendors able to deliver on what it was we needed for our FedRAMP standard. So Jamie is absolutely correct that this conversation needs to start with the core vendors in order to facilitate anybody trying to implement these systems to have any real chance of doing it. And so Jamie hit on so many good points. So who do we serve in the marketplace today? MCG literally services every market participant type, of every size. So whether that's an investor-owned utility, municipality, government agency, independent power producer, we service virtually everyone who touches the wholesale grid with this portfolio of products. So we're quite prolific. We are very well entrenched in North America, both in Canada and the US. Our business now is evolving to Europe and other parts of the world. We're quite busy in Australia. So the number of cyber exposures that we have are just proliferating. As I said, we run our own private cloud. MCG was born in the cloud. So unlike a lot of the software companies in the power space who started as on-prem delivered providers who are now trying to move to the cloud, we were born in the cloud. So I want to talk about our journey to our current FedRAMP status and the enormous challenges of that to startups and small and medium businesses. Because
Mike, are
Yeah.
you sharing slides or are you just talking without slides?
I'm talking without slides.
Okay, thank you.
Yeah. So a little bit about our private cloud. We run a highly redundant 3-site environment. Those 3 sites are interconnected with what we're now implementing 10 gigabit backbones between them. But that environment is built as an active environment, meaning other than the database level, all 3 sites are active in their service of the applications. So we use global traffic management to route customer traffic, whether that's web services or the actual applications, to all of the endpoints actively. So we are literally able to lose the internet-facing network in any environment, and it simply is taken out of the traffic management, and we're live. The database layer does not allow us to be active today, but then all of the services, the application services, which is all of the processes, if you will, the back-end processes, communicating to the ISOs, communicating to other systems, all of those run in an active setting whereby we use service queues. So if a user tells us, let's push data to the ISO, it actually goes on a service queue. And then we have services layers running actively in multiple sites that will pick up that queued item and complete the transaction. So we run active in all aspects except the database. And we believe that there really is no allowance, again, where our priority is uptime. There is zero allowance for downtime. So this active environment allows us to literally take an entire site out of operations for purposes of patching and maintenance without sacrificing downtime. So we run a model whereby the administration of our security posture is done in a zero downtime model. And with the only allowance being patching of the database servers, because that is the one time whereby you have to take something offline. But other than database patching, no other maintenance of the security posture allows for any downtime. So I want to talk a little bit about our journey to this day. And MCG was very, very fortunate in terms of how we got here versus what it would take to do this today. So we started providing these applications to the wholesale power industry in 2003. And we were doing it from our, I would call it a very immature private cloud. And people would always ask me, how do you get these utilities to allow you to host something so important? And I always used to just say, you know, they seem comfortable with it, and we've been able to engage it. So we're going to continue down that path. But in the early days, I can tell you, in early days being, you know, shortly after 2000, no one ever asked me about cyber. No one. And that's hard to believe today. And so I would call it maybe around 2010, we started getting inquiries for SOC. So at that time, we started implementing our SOC 2 and eventually added SOC 1 for a couple of our systems where we were doing a lot of financial calculations. Then later on, we were able to win a project with Bonneville Power Administration to actually do all of their power scheduling. And so today we move about $5 billion a year off the Columbia River system in real time for Bonneville. And we've been doing that for the better part of 15 years now. Through that engagement, we were required to implement NIST. I think the first version of it was 800-53 Rev 3, if I'm not mistaken. And so for a number of years then, we evolved our NIST capabilities because, of course, the first bite, you accomplish what you can, and then over a number of years, you get it to a place where it's pretty tight. But it took a number of years. Then in early 2022, we were approached by the Department of Energy and offered a sponsorship to achieve FedRAMP. And I remember that day thinking, this is both an absolutely wonderful and terrific thing, and I can't imagine how hard this is going to be. And little did I know that was the understatement of my life. But so we then started that process, and what you learn early on is that it is a very small universe around FedRAMP, and so we had to figure out who are all of the people involved in this, because of course, in order to audit FedRAMP, you have to be a 3PAO. And there are a very, very small number of them. So we ended up engaging a company called Coalfire, who does a meaningful percentage of the FedRAMP audits today. And then in addition to that, we hired a firm called Kratos, who are experts in FedRAMP, to guide us through the process. We went through just an unbelievable project because our pursuit was to achieve it at the data center level and the application level. We set out with that goal. Today, to the best of my knowledge, there are only 7 companies that have FedRAMP authorization at both the application and data center level. So it was a lofty goal. which I am happy to say that we achieved in October of 2024. And we just completed our first annual renewal of FedRAMP. But what I want to highlight there is, first and foremost, I do not know how we would have gone from ground zero to FedRAMP in a single process. We were very, very fortunate in that we were able to start with SOC and then progress to NIST. And then with NIST in a mature state to even think about embarking on FedRAMP. So what I say today is, in order to participate in wholesale power with where we're getting to in terms of the industry's demand for cyber, there is not a path for startups and small and medium businesses to participate because of how quickly the cybersecurity standards have evolved. And that's sort of the focus of my conversation here. Is how do we create an environment or an industry cyber standard that is highly secure? Because you hear people talking about diluting or watering down FedRAMP to facilitate small and medium businesses participating. And we all know that's not the right answer. Okay, it's not acceptable to dilute a cybersecurity standard when we're talking about operation of the wholesale power grid. So, but I am here to tell you that if I had to start this company today in the face of the cyber standards, I would not have gotten this company off the ground. And today we are a prolific, very important part of operating the grid every day. And so I'm trying to highlight the fact that cyber today, I'm very, very happy and pleased to see the attention it's getting, because for far too long it wasn't getting any attention at all. But I also understand the risk that it now presents to innovation. I work with a lot of the big multinational conglomerate companies in the industry, and I can tell you that they are not innovators. They, like many industries, the big companies consume viable innovators through mergers and acquisitions. But today, we're really in a chicken and egg situation whereby startups and companies that are maturing really do not have the ability or resources to comply with the cybersecurity standards as they are evolving so quickly. And that presents a real risk to innovation. And innovation, with where we stand with the complexities and challenges of this grid today, we need to make a safe place for innovation. And cybersecurity represents a risk to innovation. So a little bit about a day in the life of a small business. So for context, MCG has about 85 employees. And by the federal standards of what qualifies a company to be a small business, we qualify. So just that for context. As I said, in the early days, we were never asked about cyber. And today, we answer literally hundreds of customer cybersecurity questionnaires a year. Many of those are annually, which of course they all come this time of year. Some of them are twice a year, but bottom line is they are all unique. And so Jayson, a big part of Jayson's role is actually answering these things, and we are absolutely inundated with them, and no two are the same, and they're all over the board in terms of their focus. And so it's a great, great challenge to even be able to answer these questionnaires today. So we have NERC SIP. SIP has finally started to evolve in terms of having some clarity and specificity, but it is a long, long ways from where we feel it needs to be. We feel that there is an opportunity to classify systems. So if you take our interchange scheduling system, it doesn't have the criticality of an EMS, but it is a tool for real-time balancing of a control area or a balancing authority. We think that it is very easy to say, look, every balancing authority must run one of these, and therefore, here are the SIP guidelines around that function. We think that there is opportunity for SIP to specify cyber standards around specific functions. We also have the evolution of state ramp. State ramp is state level versions of FedRAMP. Last time I checked, I think there was 26 states launching state ramp programs. I believe that there will be 50 in short order. Those state ramp programs are derivatives of FedRAMP. Fortunately for us, thus far, the states that have launched have said that if you have FedRAMP, you're sort of grandfathered or auto-approved into their state ramp. But I need to highlight the reality that in every state where there's state ramp, they're going to pick and choose which organizations they demand to comply with their state ramp program. And I think we can all accept that anybody touching the wholesale grid, a utility or anybody who answers to their PUC is going to be required to comply with their state ramp program. And that creates a really big situation for startups and early innovators, in that if you do not have FedRAMP status, you are now going to have to comply with potentially 50 state ramp standards, in addition to your customers' individual cyber standards, where they augment in some way on their own. So it becomes a situation where for a small company, you could have as many people working in cyber as you do the rest of your business, literally, and not be keeping up. So we're very proud and grateful for our FedRAMP status, obviously. And I thought, it would be sort of the proverbial hot knife through butter, if you will, in terms of dealing with the interactions with the industry around cyber. And what we have come to find out, sadly, is that non-federal clients do not have really any meaningful familiarity with NIST and FedRAMP. Hopefully that will get bridged to some degree through the state ramp programs, but those are evolving and we really haven't gotten to see much about them. And so even though we have FedRAMP, which really goes much further than any of the standards put forth by our customers, we are not getting value in those interactions around our FedRAMP status in terms of satisfying customers' internal cyber review processes. So again, this is about risk to innovation. So I'll just flat out say it. MCG's journey to FedRAMP could not be duplicated by MCG today. We were afforded the opportunity to do this incrementally in a way that made it even remotely possible. So I want to be really clear about that. If I was back in 2003 where I started this and I had to get to FedRAMP in a year or two, there's absolutely no way I could have done it, even with the amazing, talented group we have.
Okay, so we have 10 more minutes. How many more minutes do you need, Mike?
So I'm just about to wrap up here. I will say quickly, what I advocate here is that the power industry create its own cyber standard as a derivative of FedRAMP. and one that accounts for the reality that our job is uptime versus data protection. And that we develop a standard that is rational for somebody operating critical tools to be focused on uptime and service levels. And that I would advocate for labs. Jamie talked about labs. I see labs as a very important thing, whereby groups like UND, they have labs today. Let's create labs built on those power industry defined standards where we can develop and train cyber engineers, and then startups and early stage companies can certify their applications to the standard without this enormous cost that they cannot bear and that VC and private equity will not fund. So I realize I'm running out of time, but that's my pitch. I wanted to leave a few minutes for Jayson to talk about just a handful of examples. So I'm kind of highlighting the risk. I wanted to give Jayson just a couple of minutes to highlight some real world examples that we deal with that really, if we were to develop our own power industry standard, we could hopefully make go away, but that are huge hurdles to us on a day-to-day basis. I apologize for running along, Jayson, but if you could just give us a few in the trenches realities.
Sure. Thanks, Mike. Clearly very passionate about this. So thank you, Mike. For those of you who don't know, FedRAMP is the Federal Risk and Authorization Management Program. So it's focused on cloud service providers and establishing a standard. It is based on NIST standards. The most current is NIST SP 853 Rev 5. So it is very robust. Although it's very flexible, it's not quite as prescriptive as some of the others. One of the points I wanted to touch on is there's a very strict and rigid approach to vulnerability management. So based on CVSS score. So in CVSS score calculation, it's not very contextual. So it assesses a score, and you need to, in true letter of adherence, you have 30 days to remediate that critical finding, 90 days to do a moderate, 180 days to do a low. It gives no context to do a pragmatic, rational, contextual risk calculation. So I would say, an edge device that's exposed to the internet with a vulnerability is far more risky than an internal database server that has 5 compensating controls and layers of segmentation to protect it. So taking that more contextual, rational approach and truly assessing the risk to your devices is far better than a rote CVSS score. I understand you need to start someplace, but and drive the conversation and understand that risk calculation. But from a high level, big bucket, breaking it down into now, never, now, next, never, and never with a caveat of compensating controls, low cost, high impact controls is a more rational, reasonable approach to that vulnerability management. 20 plus years in this journey for Mike from cloud hosted in the early 2000s, it's very clear that uptime availability is key. With FedRAMP, it brings uptime availability and security and vulnerability management. And when you've got a small company without a very large dedicated security team that's focused on the operation and uptime to the business, it's a challenge because it's additional duties as assigned to the whole organization. But it's very clear from Mike's passion that it is important, and as he said, it's all about the availability and the integrity to the critical infrastructure industry. And kind of dovetailing to what Jamie was saying earlier, it's being brilliant with the basics. Take care of your core principles. You can't be perfect. There is no perfect. There's not enough money to be perfect. So those core compensating controls, firewall rules, multi-factor authentication, segmentation or micro-segmentation, that's what's going to bring you the biggest benefit. And I know we're running on time, so I'll cede the floor to questions. Thank you.
Folks can put their questions on the chat, please. Okay, so we have Maria. How can one have single infrastructure to run one and only application and do all services?
So Mike, I can take that if you want. So we have a common infrastructure platform. There's not a single server or a single network device. So there are layers, there are tiers. There's a web tier, there's an app tier, there's a database tier. We utilize quite a bit of network load balancing, both from the from the DNS layer, the application layer, the server hosting layer. It is very much distributed horizontally in that way, but it's a single architecture of the infrastructure.
Thank you, Jayson. Yeah, Maria, do you have another questions or something?
No, I don't know if you can you hear me?
Yes.
Yes, I can.
Oh, okay. I just wanted to ask, so it's interactive basically. You know, you have these different services and they talk to each other and exchange data, or what information do they exchange? Because you went all over, survey a market, doing, you know, things like connecting the interconnections and stuff like that. It sounds like the back end is doing everything that SCADA used to do. I'm very confused with what you are saying here.
Yeah. So for example, if I'm sitting on a generation management desk and I say, okay, that is my bid stack for my generators going into the ISO for tomorrow's market. So I've got all my generation attributes, my price points, and I say, click the button, submit it to the ISO. Our application doesn't actually submit it to the ISO. It puts it on a service queue. Then we have a whole series of servers that run services to look at those service queues, pick up that piece of work, and communicate it to the ISO. So not the actual application that the users interact with don't actually push data to anything other than to our own services layer.
Great, thank you.
Yes.
Okay, let's see if we have other questions. Oh, there's another question coming in. What kind of innovation qualifies the expectation of innovation from your perspective?
Well, you know, I don't know if everybody here is familiar with a company called Open Access Technologies International. They are also here in Minneapolis. We together control about 98% of what is called e-tagging. E-tagging is the communication protocol for real-time power flows. So if I want to move power from point A to point B in the real time, I have to submit an e-tag. It is a power flow communication protocol. We, between us, control about 98% of the marketplace in North America. We are both startups here in Minneapolis. You know, we joke and we say, you know, our data centers are just literally miles apart. And we literally say that 98% of physical power flows in the North American grid happen in about a 4-mile stretch in Minneapolis. We're both startups, and quite literally, neither company would exist today had we had to comply with the cyber standards we have today without something in the form of a more focused standard, and I believe in these labs. So I'm talking about companies that literally have very little seed money. They have a big ambition, a big goal, and their resources are limited to payroll and not much else in the early days. And trying to just get a viable 1.0 product that they could take to the world and try to start commercializing.
Hey, thank you, Mike and Jayson. I think we have only 2 minutes at the interest of time. I think I don't see any other questions. Any last minute question from anybody on the chat? Okay.
Yeah, so can the standardization be automated? That's exactly it. So today, Jamie talked about scanning. We used a platform called Qualys. Qualys is constantly updated for the FedRAMP standard. So one of the things that I'm advocating for is a power industry derivative of FedRAMP that then a company like Qualys can create a scan pack for, and that we can automate the scanning of it based on our own industry standard.
Super. Thank you, Mike and Jayson, for your time. I think that concludes this session. I appreciate Mike and Jayson for being here with us. Thank you again so much for being here.
Thank you for the opportunity.
Thank you.
Let's move on to the next session. Okay, so the next session, before we hit the lunch break, is Control of Solid-State Transformers by Rasel Mahmud, Lead Power System Engineer, New York Power Authority. Rasel is a power system engineer and researcher specializing in inverter-based resource modeling, protection, and grid integration studies. He currently serves as a lead power system engineer at New York Power Authority's Advanced Grid Innovation Laboratory for Energy, where he advances simulation, modeling, and protection research for renewable-rich grids. Previously at NREL, Rasel led multiple DOE, DOD, and industry-funded projects focused on AMT and reduced order modeling for IBRs. He is completing his PhD in systems engineering at Colorado State University with research centered on reduced order modeling and protection grade analysis of inverter-based resources under fault condition. Rasel, thank you for being here. The floor is yours.
Thank you, Dr. Prakash. Just checking mic. Can you hear me?
I can hear you. Can you share your screen?
Yes. Give me a second, please.
Rasel is also a UND grad.
Yes. Okay. Where's my...
Do you want us to share your slide? I think we have your slide, or you have it.
Oh, yeah. I'm gonna share it. I'm just taking some time to juggle between multiple monitors.
We can see your busy traffic behind your video, and we don't see that big busy traffic in North Dakota. So
yeah.
Okay, the time is you can start. We can see. Yeah.
Okay. Yeah. Sure. Today, standards for solid-state transformer, compliance of the standard requirements, and
You're getting frozen, Rasel. We can't hear you properly. Tanzim, you know what's going on? Oh yeah. Oh, you're back. Okay, good.
Oh, okay. Okay, so I'm going to repeat again if the mic was muted. So hi everyone. I'm going to present today applicable standards for solid-state transformer and their different requirements, and also in relation to all these standards, how we can make the function and functionalities of solid-state transformer cyber resilient, considering different threats. While I present the material, just wanted to put the disclaimer that none of the materials presented today are view of NYPA or my previous employer NREL. These are my observations, findings, and NYPA or NREL do not endorse any specific standard, organization, or commercial product that will be specified here or mentioned here. So given that, we can jump to the main part. So the agenda for today's talk is basically on a high level, what is solid-state transformer? What are the grid interconnection standards? What are the standards for safety and electromagnetic compatibility, EMC standards? And solid-state transformers can come in different flavors. It might have multiple ports instead of the traditional two-port power electronic converters. So what are the considerations we have to make for multi-port converter consideration? And then, given all these standards, how we can make sure that the farmer are actually true to the intended function, they're designed, they're not deviating. So how we can verify and validate, how we can make it cyber secure, and some compliance roadmap and test metrics. So solid state transformer, these are specialized power electronic converter where we have high frequency transformers inside the converters. So for comparison, the line frequency transformer will be 60 hertz, but a high frequency transformer will be several kilohertz. So you can see the difference. And then there would be stages of AC to DC, DC to AC conversion to make it compatible with the actual interconnection point. It could be in the grid side, AC side, or it could be connecting some DC source. And then typically the solid state transformers can be connected at the medium voltage or even the low voltage as the interface for different kind of sources like PV energy storage or wind. You can even connect multiple sources like PV and wind, or combination of PV energy storage, wind, to the grid through a single converter. EV fast charging is another example of application. And then depending on how you're configuring your system, you can use them in microgrid or other industries wherever it's applicable. The good thing about this type of converters is that they allow bidirectional power flow, and they are very controllable devices, meaning that you can have very accurate control of your active reactive power. You can use them as like voltage regulations, voltage regulatory device, and you can use them for even coordination of the making your system like more resilient or high performing through dynamic coordination. So basically, though it's a transformer, the traditional transformers are actually very passive. You don't have that much control, and the function of traditional transformer is mostly like basically voltage isolation and change of voltage in the AC system. But the solid state transformer can do that as well as much more. It can be act as a gateway to interconnect many things with the grid in a very flexible way. So the standard stack for these type of converters are actually huge. That we have to think about on the device level. And when we say device level, like for the converters, we have to make sure that it's safe. It's complying with the EMC requirements. It's not actually polluting the EMC spectrum of the grid, and is resilient to the different disturbances coming from the grid as EMC disturbances. And it's cyber secure. It has a valid verifiable software development life cycle. On the system level, these are not standalone equipment. We are connecting these equipments or the converters with the grid. So we have the interconnection requirements from the grid side. We have the protection requirements, and there are specific standards for these requirements. And also, depending on where we are connecting it, are we connecting at the distribution level or the transmission level? Other standards might come into play. And also, just a note here is that actual mandatory requirements will come from the jurisdiction or the utilities that where the converters is being connected. These standards are specifies or suggest that these things can be done, but the actual mandatory requirement will be done through or specified through the local utilities where it is being connected. And we already mentioned that we have to think about both as a solid state transformer SST as a product, so that they're safe, and also as a system, because then when you are connecting them, they're becoming part of a larger system. So they also have to be compatible with those that environment, system environment. And when we are designing the SSTs or trying to understand what are the requirements, we have to factor in both. So the requirements for the SST during design stage have to factor both of these environments, and they have to understand what are the associated hazards to meet all of these requirements, and then the design architecture has to be defined accordingly. And once these things are done, we have the proper design architecture, the product in place, then we have to have a test plan for verifying that it's actually meeting all these requirements. And of course, we need to make sure that we are documenting everything. So we'll go deeper into the grid interconnection requirements. So as the converter can connect with the grid, they can connect different type of like sources, PV energy storage, or any other sources. So in that way, it looks like a inverter. So an inverter, all the interfacing grid interconnection requirements that applies to all these inverter-based resources, in that case, applies to the SST. And then they have to do the voltage and frequency right-through, meet the voltage and frequency right-through requirements. They have to meet the active and reactive power controllability requirement, and they also have to do the communication interface requirement. And with these requirements, there are specific interconnection testing rules. They have to, the converter has to be certified using the conventional EVL certification process. And then if it is connecting to the grid, connecting to the transmission grid, in that case, there is a standard for IEEE 2800, which specifies the requirement for grid bulk power system connected requirements. And these are more rigorous compared to the IEEE 1547 we described earlier, which is the distribution connected requirement. So basically, in that case, the SST has to not only write through, but it has to support symmetrical, asymmetrical, like it has to provide support during symmetrical, asymmetrical faults to the grid, and it has to have some dynamic, like frequency and voltage support capability with dynamic limits, and also need to coordinate with the grid for protection system, and it has specific recovery ramp limit when it's recovering from the faulted operation. And for this, we have IEEE 2800.1. This is not a published document yet, but for the IEEE 2800 specification, the testing document would be 2800. This is a work in progress via IEEE. So yeah, and they also have to support depending on what is the objective grid forming or grid following mode of operation. So as we are saying that there are different interconnection requirements depending on where it's connecting and what type of control is going to have. Is it grid forming or grid following? The specific point to consider for SST is that these are multi-port converters. So that means that each of the ports have to meet these requirements separately. These ports internally do a lot of like interactions. They have a lot of internal logics to coordinate their performance, but the internal logic should not impede in meeting the requirements in each of the applicable ports. So this is a very specific case for SST compared to other two-port devices. And for testing of this, when we are going to verify that, we have to actually test these scenarios where we apply different faults in one port and like different events in one port and see whether the other port is still being able to meet the requirements or not. So basically, we have to demonstrate that each of these ports are individually able to meet these requirements. And then for the interconnection requirement, we have this communication standard, the traditional ISE 61850 standard, and then also we have the DER level standard like IEEE 2030.5. DNP3 is a very popular protocol, communication protocol for this type of converters. And then also we have the IEEE 1815.1. That's like a mapping between DNP3 and 61850. And all of this has to while meeting these communication protocol requirements, so basically they should have this capabilities to communicate through these channels. The performance when the communicated signals is tested should meet the expected requirement, like when the latency should be within the accepted range. If there is any fault, they should do the peer-to-peer fault isolation so that it doesn't propagate to other ports and things like that. So, and basically this will give the real-time data exchange capability for the SST controller with the external environment. And depending on where it's connected, if it is connected to the transmission network directly, or if there is a reason to believe that the plant is going to impact the transmission level behavior, then we have the all bulk power system related requirements. So basically these are guided by NERC. There are lots of cybersecurity related standard, protection and control related standard, transmission operation related standard. So so individual converter might not be able to have that much power level, but often these SSTs can be used in a plant which can make a big enough size that they are going to influence the BES bulk power system. So in that case, we have to coordinate with this NERC levels regulation or guides. So next we're going to discuss about, so we discussed the interconnection requirements. What about the device itself, whether it's safe to operate or whether it's immune to all the electromagnetic disturbances that can go back and forth from the grid to the device. So for the system level safety that is defined by the what is the electrical shock hazard, what would be the installation level requirements, what would be the fire and mechanical failure protection mechanism. And for this kind of safety related requirements, we have IEC 62477-1, if it is like low voltage. But if we go below, above that voltage, like 1 kilovolt AC, more than 1 kilovolt AC, or 1.5 kilovolt for DC, then we have the -2 requirements. These are general power electronic converter system requirements, but they're also applicable to the core functional, like they're applicable for the core design of the SSTs, so that the SST as a unit is safe. And for the safety testing, we have this dielectric and installation coordination testing. We need to do the predictive bonding and fault kind interaction verification. We need to do the abnormal operation test, temperature rise, and component variation validation. So these are like a very rigorous testing, and mostly these things go into the design stage of the SST. And of course, we have to make proper documentation of all this testing to make sure that when the converter goes into the market, there is enough documented evidence that the converter is safe for operation. Other than the safety requirement, there is a huge list of EMC, electromagnetic compatibility requirements. And this is where things get really complicated, because there are a lot of generic EMC requirements for 6100-6-6-4 for emission requirements, and -6-2 for immunity requirement. But these are general purpose. Most of the time, the converters are very high power, like it can be, the individual converter can go even megawatt range. So in that case, the generic industrial standards might not be applicable. So depending on what is being connected, there are some product-specific EMC standards that has to then be looked at. So for example, for EV conductive charging, we have IEC 61851-21-2. And similarly for energy storage and PV, we have some other standards. Again, these are product specific standard, but not specifically designed for solid state converter. But in the absence of any requirement, solid state specific EMC requirements as of now, we have to look at like which one is closest that we can use for the requirement document. And then there are corresponding test method documents to verify that these requirements are being met by the SST. There are several generic testing document, and the product specific document also provides some like some guideline how this testing can be done, given that these converters or the SSTs are going to be used in a specific environment for like EV charging or PV or energy storage application. But this is still a evolving standard situation. It's still evolving. But as I was saying, we have to, depending on the scenario, we have to go into the closest match for the specific situation. And then depending on what we have, find that which EMC standard is applicable, we can either use the testing for use the generic requirement or the product specific requirement. And there are a lot of those standards for this kind of testing. And one more thing here is that for United States, we have FCC Part 15 for this kind of like EMC standard requirements, but ISA standards are more generally more developed. But if FCC Part 15 is applicable, is found that is applicable depending on the power rating, depending on where it's being used, that can be used as well. Otherwise, we have to look at the specific situation. So when the converters are being designed, then both of these aspect has to be looked at, the safety aspect and the EMC aspect. Just looking at one aspect will not provide a very good design, because then the other one will be missing, and that will be a problem. So that has to be a coordinated design for considering both the safety requirements and the EMC related standards. Then and now this becomes another interesting thing, is that we already touched this a little bit, that this SSTs are multi-port converters, and there are a lot of design variations in these converters. There could be like multiple isolated ports, there could be non-isolated ports, and they can actually make a lot of difference between like how the converters can be connected with the grid. what are the requirements that can be traced from the DC side to the AC side, that we are not actually conflicting or creating any problem, neither on the DC side, neither on the AC side. And these are bidirectional power flow converters, so power can go actually both sides. So 62477, these are basic safety requirements. We already discussed that. But then beyond these requirements, we have IEC 62909-1. That is the general requirement for bidirectional grid-connected converters, which extends that IEC 62477 for energy storage application. And then for the harmonic content, there are a lot of other standards as well, but some of the relevant standard is IEC 62076-57-129, which helps which defines the converter transformer requirements for the converter transformer. As we already mentioned that the SSTs will have a high frequency transformer inside it, and so the converter transformer requirements for those transformer and harmonic current capability requirement for those transformers are provided in this standard. And then also, of course, the port level interconnection and interoperability requirement will be defined by IEEE 1547 or 2800. And depending on the communication, it could be 61850 or DNP3 or 2030.5 for the communication requirements. So, so basically, all these things boils down to that when dealing with these multi-port converters, there should be, in coordination with these standards, there should be defined permissible power transfer sequence and energy routing logic, so that the multiple ports are coordinated. They are not creating any like conflict with each other or creating a situation where it becomes a safety hazard. And it doesn't, so that, and also we need to make sure that the fault related to one port or inside the port or outside of one port doesn't propagate to other ports. Many times these ports can exchange power independently from any port to any port. So this is really important that we are allowing the power whenever it's safe to do that, but we are not allowing any fault to propagate from one port to a faulty port to a healthy port. And then of course all these things has to be selected like a time scale. The timing is important, and protection hierarchies across different ports needs to be defined according to this requirement. So basically, the testing, we can do all this testing, all the testing requirement related to this, like the protection logics, and demonstrate. The demonstration goal would be that it's safe isolation. It has safe isolation, coordinated protection, and resilience under port-to-port fault scenarios. So these are like as of now, but as I was saying, the multi-port converter is or the SST, solid state transformers, are as a product. The concept, the theoretical concepts are not that much new, but as like commercial products, these are very new thing. You probably will find very few vendors in the market that have these kind of products, but they have huge potential. So given these scenarios that these products are coming online, coming to the market, and given this the promise they provide for like interconnection defined kind of sources and eliminates a lot of intermediate stages. So considering all these things, there are heavy activity going on in defining new standards and understanding new topologies, technologies that are being introduced so that these standards can actually accommodate or address all these the new technologies coming into the market. A specific, in this regard, a specific standard is IEEE P3105. This is a ongoing standard development work under IEEE to address the interoperability and test procedures for SSTs and multi-port converters. We discussed all these requirements that the converters, the SSTs have to do under different scenarios. They have to be safe. They have to be interoperable with the grid. So all these things are actually, most of these things are actually software defined. Of course, there are a lot of hardware design. A lot of things goes in the hardware design, and once the hardware is designed, hardware is set, hardware is not changing, right? But what is changing is the software, and many of these requirements are actually software defined. They are not they can change on the go, where you can, with the change of a firmware, you can do a lot of changes in the behavior. The SSTs can behave, and that determines whether the SSTs are actually meeting all this, the huge list of standards that we just discussed. So now it's a challenge to make sure that any change in the firmware is actually doing exactly the things that that is intended. It's not doing some unintentional thing, unintentional change in the functionalities of the converter, or it's not introducing some response that are non-compliant to all the standard requirements that we just discussed. So this needs a rigorous verification and validation framework, so that firmware change doesn't make the converters non-compliant. So for this kind of, to address this problem, we have this testing called regression and non-regression testing. So basically, what the regression testing is doing is that whenever there is a change in firmware, it does curate a set of functionality, safety, and performance tests to see is this performance is as expected, to detect whether there is any malfunction or unintended behavior because of the change of the firmware, and also to make sure that it has backward compatibility and the converter stability is there. It's not losing stability because of a change in the code of the firmware. And then the non-regression testing is this is also actually testing the the converter is actually behaving as intended. It's not doing something else, but it's like a smaller test, focus a subset of tests based on impact analysis. It confirms that unmodified functions will still be behaving as expected with respect to the modified functions, and it's only mostly used when a limited firmware change is done. And there are actually standards for this this kind of testing, and this is interesting for me because I'm a power system engineer and also background in powertronics. So the interconnection standard requirements or the safety requirements, I'm very familiar with these kind of things. But as we were working on a project where we are trying to make a converter compliant to these standards, then we realized that there are additional things need to be there, such as this regression and non-regression testing as a safeguard that any future change doesn't make any unexpected behavior change, and then these are whole different range of other software and cybersecurity related standards that can help us with that defining those processes. So for the applicable standards for farmer verification and validation process, IEC 61508-3, these are for functional safety lifecycle requirements, requires validation, change management, and regression test after any software modification. And then we have IEEE 29119, which defines the structure and documentation for software test plan procedure and traceability. And then for the software product development lifecycle management, which helps with which defines the how to make a secure design, how to verify that the design is secure and manage the vulnerabilities. We have IEC 62443-4-1, and for the testing of cybersecurity related testing, when these converters are in a network connected environment, we have UL 2900-1, and also we have this NIST SP 800-218, which provides a US federal-based baselines for secure development and testing. All these requirements actually come into play when we want to make these SSTs safe and secure. And when we are going to test these requirements, test that as a whole, the system is like safe and secure, and we are doing, the farmers are actually doing what they are supposed to do. We have to go stages, or like look at this problem at different stages as unit tests. Unit tests is like the individual components inside the converter. It could be PLL, it could be the current limiter or the current controller, whether they're working or not. And then from there, we have to go to the integrated system, like the converter itself, so that the subsystem and the control SST is working as intended, and the communication is working. So once that is done, integration test of the subsystem so that the SST is working as appropriate, then we have to go in stages, it's not like we have to go, but these are stages that can be tested. The actual test sequence actually will be dependent on the vendor or the manufacturer. So we have the software in the loop test to run different simulation for the farmer, and then we have hardware in the loop. The farmer, just testing the farmer only without the hardware is not always like good to capture all the things that would be interested, but it definitely helps to identify, test and validate a lot of things with very low cost. But the hardware in the loop test will definitely provide much better, greater insight about behavior of the converters. And then of course the system test is like you put it in the actual environment and see how it does. So, and since these things takes a lot of testing, each of you can see there are a lot of stages to test, and a lot of in individual stages there are a lot of standard related requirements and a lot of like the verification and validation related requirements. So it would be like a almost essential. It's not like if you can do manually, that's okay, but it would be probably prohibitively time consuming. So you need to do this automation so that all these testing scenarios, different conditions are automated. You have a continuous development pipeline, and you record what you are seeing, what you are, and can like justify what you were seeing. So with that, we can define different quality gates to understand how the SST is actually doing in terms of all these requirements. So the functional gate would be basically all the interconnection requirements and protection tests, such as those requirements coming from IEEE 1547, 2800. And you run the test, change the voltage, see if it is doing the expected reactive power regulation or not, things like that. And then we have this safety gate. We run different disturbance situations. We try to short circuit the terminals to see if it safely isolates, detects the short circuit and isolates the converter or not. So these are actual testing, and we have to pass those test procedures or the steps. And all these tests and when done, then we also have to see that these changes or we are not putting the device or the equipment in a situation that it will be a stability problem. So basically, it should be stable within its given boundary, and not only within this given boundary, it should be stable within its any firmware change cycle. So that has to be ensured. And CyberGate is like, we need to make sure that all the piece of the software cores are safe, all the communication that is doing with external environment is cyber secure. There are cybersecurity requirements for that. So once all this, we're calling this gate, but basically this is like different stages. So basically all these stages are confirmed that passed, then the firmware can be say that it has passed all the requirements, and then it could be put into the release stage. So yeah, and a similar thing can be done for the using the non-regression testing, but the non-regression testing, as I was saying, is like more focused on small change within the farmer, and eventually just to see that it's not doing any adverse effects. It still can be put in the continuous improvement or the validation chain you can, if you want, you can do the whole suite of testing, but probably you don't need that. You just run some selected tests and see if it is working or not. And given all this huge pipeline or huge requirement of testing is almost essential to have a automated continuous improvement and continuous development framework that can put the different pieces in a corresponding automated test environment and run all the testing requirements so that it actually passes all the requirements. Yeah, so basically we have to pass this regression and non-regression testing, and for this kind of testing, we have ISE 61510-8-3 to 9119, 62449. These frameworks can help with this firmware verification and validation testing. Cybersecurity expectation. These are highly controllable equipment. They communicate with external environment. So it's essential, it's like obvious that we need to make sure that these are cyber secured. So the general cybersecurity protocols or the requirements apply here. We have this IEC 62443 series industrial automation and control system security standard for product development lifecycle requirements and technical security requirements for embedded devices. These are embedded devices. And we also have this NIST SP 200-218 for software development, secure software development framework. These are like general purpose requirement. IEEE 1547.3 also is a specific DR related requirement that can be used for the SSTs, and that will address some of the specific cybersecurity aspects other than the general ones for the DR connecting, for the equipment connecting the DRs. In this case, the SST is actually equipment connecting the DERs. And we already discussed the EVL 2900-1 and CIP, NERC CIP. NERC CIP will be applicable if the system is going to influence the bulk water system or being connected to the bulk water system. So for the secure development lifecycle practice, we need to identify the threat model, security objectives in the early stage of the design. We have to define the access control, authentication, and update policies. And then we have to apply the secure coding guidelines, static analysis, and peer review. So enforce code signing and version control integrity. And also, of course, we have to do the verification and validation using vulnerability scan, fast testing, penetration testing, and before releasing the patches or the updates for the farmers, we have to do proper patch management and vulnerability disclosure workflow. And this is really important because many of the times the SSTs are actually developed by engineers who are who specializes in power electronics, or sometimes power system engineers also can be part of the team. But the cybersecurity related requirements are actually need someone who has more specialized like knowledge in this domain. So in the team is like the core design of the converter, the SST can come from the power electronic engineer, power test engineer, but at some point, someone more knowledgeable with the cybersecurity aspect and software design will have to be bring into the team. Yeah, and then we have this the new requirements coming from the NTIA and CISA. So basically, all the softwares has to like this is a software bill of material. So all the softwares, license libraries has to be traceable, and we need to have a checklist of verifiable software origin, and then we have to make sure that the supply chain management is ensuring that supply chain we have to use proper supply chain risk management so that we can manage the common vulnerabilities and exposures for all dependencies of the firmware. So the end goal is that we have a complete end-to-end visibility from code to deployed firmware, where we know which one is what, and each of the pieces, components, libraries, licenses are actually secured from end to end. So this we talked about a lot of this discussion that we did is actually on the design stage, but it also goes into the operational stage where the cybersecurity has to be ensured through proper cybersecurity operation. And actually there for this operational stage security challenges, we have specific guidelines like NSDSP 800-82. We have IEC 62351 for encryption and authentication, and IEC 61850-90-2 for cybersecurity extensions. So yeah, and all of this, the requirements has to be tested, validated, and proper documentation needs to be maintained so that anytime is needed, a safety check can be done during operational stage or development stage. So basically, the goal is to demonstrate a provable, repeatable, auditable cybersecurity posture aligned with ISE 62443-4-1 and SSTF. So Yeah, and we talked a lot about this requirements, cybersecurity requirements, and farmer validation requirements. So the way we can do it, we define this, need to identify the requirements, all these requirements, everything from the interconnection requirements to the cybersecurity requirements. Then we have to, we can go into the design and architecture stage, and then we can go to the prototype validation. Certification is a big part of this, all the standards that we just discussed, and field operation. Even though, and one important thing here is that even though we have it as like different stages or phases, phase 0, phase 1, things like that, it's not like linear. They are iterative. They can like at different all the stages, whenever there is something found, it can go back to the requirement definition. The next version of the SST can incorporate whatever is found in the present iteration of phase. And then we have some high-level integrated test metrics. So basically, we have to test and validate is safe, is EMC compatible, the SST is meeting the interconnection requirements, the SST is doing the right protection coordination and is communicating with the right communication protocols. It has fiber right farmer management system, and is a cybersecurity system. So we already discussed these things. I'll go quickly because we don't have much time. So common pitfalls. Treating SST as a passive transformer is not a passive transformer, it's a highly controllable equipment. So we have to acknowledge that and use appropriate standard for the requirement analysis. And then second pitfall is that the port-to-port, treating ports individually is one of the important things. The ports can communicate and interact with each other heavily, so we need to make sure that each of the ports can meet the requirements, even though other thing, even fault can happen in other ports. For the EMC requirements, they have to meet different dynamic loading conditions. For the farmer update management system, missing regression linkage after farmer update is one of the like a pitfall. So we have to automate the continuous improvement and development stage. And of course, all the software components has to be traceable. Yeah, so compliance spans, hardware, firmware, and cybersecurity all must align. So once everything is checked, then we can actually say that the SST is reliable, safe, and secure. So with that, I conclude my talk and see if we have any question, comment.
Thank you. I think we have folks can put their questions on the chat, and I think we have one question already from Maria. Maria, do you want to ask that question?
Yes. Sorry. Okay. I don't think. Okay. Can you hear now? Yeah.
Yes.
Okay. Thank you, Rasel. I'm a little confused. There are million standards here. And, you know, as it was said before, it just gets so complicated that nobody can put that as an SST on the system. My very specific question is, let's say take 1547 that we have for inverters. Is it really true that if you test it offline, when you put it on NYPA or you put it in ISO New England, you'll get the same performance voltage right through? That's not true. So how do you deal with checking system performance of SST or other devices?
Yeah, thank you. These are very interesting questions. And I guess the standardization.
Your audio got cut, Rasel.
Interact with each other.
We can't. Can you speak up again? We missed you. I don't know what happened.
I guess the reason that I'm asking this question is to put it in context of the previous talk that we had about, look, I'll never make it if I'm going to make build one of these SSTs and stuff like that, because there's so many standards and so much testing. And some of those are really, they came from historic things that don't apply anymore really to the way utilities work now with inverter-based resources. So anyway, long story short is, how do you ensure that system level standard is met when you test your SST?
Yeah. Can you hear me now?
Yes.
Yeah, sure. I think I was cut off. So basically, the standard committee is actually working on this question. This is a very relevant question, and individual performance doesn't necessarily mean that the system level performance will be same. I believe one approach to address this question is running HIL, so that that it has some interaction going on with the network model running with the HL environment and the equipment running, or the converter running in the hardware space. So that's one way, but that doesn't necessarily mean that it's going to ensure that it will actually be compliant under a actual implementation. I think there's still a research question or open question to how to address this effectively.
I'm trying to, address the question in context. I don't know if you heard us in context of, there are so many standards. I mean, I couldn't follow everything that you said, and who in the world is going to test all of these? If I were to build this, as I'm a power electronics business, I want to build these SSTs. Is your lab trying to automate that to help with, or what's going on?
So my current employer, the lab that I'm working at, it doesn't do that. So but by the previous workplace, Enril, they do a lot of this kind of work. So many of the work coming out of Enril and other national labs can also help in addressing or automating many of these processes. But at the end of the day, you have to get, for many of these requirements, you have to get some certification, and the certification will come from some testing agency. So it has to be. The burden goes to most of the time goes to the manufacturer or vendor who is supplying the product to ensure that it's actually meeting these requirements. But yes, I get your point. It's a very complicated process. We'll need a more automated process, open source process, or like a easy automated process that can help reduce the cost and time to test all these requirements.
Okay. I think Maria's question is very appropriate. Isn't performance system dependent? I think more standards needs to address that.
We can add another standard for that.
Thank you, Maria, for this next wonderful question. I think we have another question from Professor Brian Johnson, I think. When you talk about the need, Brian, do you want to ask the question? Are you there? Or do you want me to read it? Maybe I should just... when you talk about needing HIL testing for SSTs, who will be doing these and ensuring the compliance? Yeah. The end users don't have the resources to do all of these testing at their level.
Same question,
yeah. Some of the...
yeah.
Okay, good. So,
well, if I can jump into that, even I heard from some developers of this similar technology, they cannot get on the system because it's not a proven technology yet. So at what point does this become proven technology that we know is that it should work, that this device should be working somewhere in real system, or what is the proven technology here?
So yeah, I think it's a gradual process, but there are actually SSTs installed in actual system, though those are like not conventionally certified. with all those requirements, but with some special arrangements and in some cases in a lab control environment they are installed. So these experiences provide some evidence, like in terms of how they're doing. Are they doing expected, or they're not doing as expected? So that's phase, like one way to look at it. The other way is we can test them to some extent in the lab, such as at NREL, there's a huge capability to test them to the extent possible to create a very close real life scenarios. But at some point, you have to take some risk, right? Otherwise, these products will not come into life. They will be, yeah. So we do have some evidence that how they're performing from some limited field test and some extensive laboratory tests, but that doesn't necessarily guarantee. So we have to take that the additional risk.
Okay, we're almost time, and I think any other questions before we do go to lunch? There's so many standards out there, Maria. I know that. It's really, I don't know how to answer that question.
Yeah, it's very, yeah, it's hard to keep track of all the standards.
Okay, with that, Rasel, thank you for being here this morning with us, and I think appreciate for taking the time to share what you have. And with that, we'll take an hour break for lunch, and so we can come back in an hour. And then Sriram, can you show the schedule for the rest of the afternoon so we can see what the schedule is? Thank you, Rasel.
Yep. Thank you for the opportunity.
So when we come back at 1, we have Assaf Turner from CEO from Maya Security is going to give a talk on his approach on cybersecurity for critical infrastructures. And then we have followed by George Mason University, and UND will also share some new initiative, what we're doing on the Critical Infrastructure Center. And then you have Professor Maria is going to join us from MIT. She's going to share her work on power electronics dominated grids, and followed by Charley Cunningham from City of Sacramento will be there and to share his case studies on some operational resilience, and also from ANL. Siby is going to talk about some DER and cloud supported edge work, which is a DOE funded work. And finally, we have Andrew is going to share cyber-informed engineering. So we have a lot of interesting talks coming up. Stay tuned. I'll let you guys go for a virtual lunch. Thank you.
Thank you.
Okay. Good afternoon, everyone. We're going to get started for the afternoon session. Thank you again for being here for the afternoon session for this summit. We're going to continue with our afternoon session. The next session is titled Proactive Cybersecurity and Critical Infrastructure, the Case for Adaptive Cybersecurity and Continuous Monitoring, from Joseph Assaf Turner, CEO and founder, Maya Security. He's joining from Jerusalem. Joseph is founder and CEO of Maya Security, former head of cybersecurity unit at Ministry of Energy, and leading cybersecurity strategists specializing in protecting and critical infrastructure and OT environments. With over 25 years of experience advising energy regulators, utilities, and industrial operators, he has helped shape national frameworks for resilience and compliance. His work bridges the gap between the policy and practice, aligning standards such as IEC 62443, NIST CSF2, and energy regulations into actionable defense programs. Under his leadership, Maya Security has become a trusted partner for governments and industry in developing a proactive, intelligence-driven cybersecurity ecosystem that enable critical infrastructure to anticipate and withstand emerging threats. With that said, Joseph, thank you again for being here with us at UND and INL for this workshop, and the floor is yours.
Thank you, Prakash. Let me share my screen.
It's coming. It's not yet showing up. Is Matt there, or
Okay.
are you able to share the screen?
How about now?
Okay, go ahead.
Excellent. So, good afternoon, everyone. I hope you had a good lunch. It is 9 p.m. in Jerusalem, Israel. A little bit of a time gap. So, again, Prakash, thank you for having me. I'll talk for about 30, 20 minutes maybe about proactive cybersecurity and critical infrastructure. A little bit about me so you can get the gist of the background even after Prakash's amazing intro. Basically, founder and CEO of MySecurity. What we do cybersecurity for IT firms. We're doing OT cybersecurity and specializing in the energy sector. We're experts in critical infrastructure, OT, IT defenses, and I started my personal humble career in 1999, back when Windows 2000 was a thing. By the way, side note, hopefully everyone was able to update their systems for Patch Tuesday. Former head of the Ministry of Energy Cybersecurity section, in that role, which I left earlier this year. I was in charge of regulating and doing cybersecurity for the Israeli energy sector, meaning mostly producers, vendors, and the regulation that goes for everyone. Let me start a little bit about our landscape and when we're talking about cybersecurity and critical infrastructure. So when we're talking about cyber attacks, and it used to be very difficult to get data, and today data comes in almost seamlessly and online. We're seeing basically a lot of attacks. We've been seeing 1162 cyber attacks in 2024, which is a 70% increase year over year. And according to IBM X-Force, and this is we need to take this with a grain of salt. 70% of their attacks are attributed to critical infrastructure in 2024 and 25. And this is a huge number. It used to be where our, as governments and the entire industrial field, I would say, we weren't really afraid, or we weren't really dealing with a lot of cyber attacks. It's a different animal. I'll go into that in a bit. But we're seeing, and I'll go into that in a couple of seconds. We're seeing the focus going on to critical infrastructure and the energy sector, which is part of that. Again, when we're talking about 54, over half of critical sector incidents, we're talking about ransomware. One of the examples which I was able to dig up was an energy operator in Southeast Asia. They suffered an 18-day outage. The ransom demand was $8 million. And calculating or estimating the operational loss on those 18 days, we came up to anywhere between 45 and $60 million. And that's a conservative estimation. So you're seeing that this trend is, well, first off, any management would basically jump at their wallet to pay that $8 million and not suffer another day of shutdown. But you are seeing the way that this trend is going to keep growing for the next few years at least. We're looking at, like I said, increased focus on regional electricity operators, if it's distribution, production, transport, ICS and SCADA systems do remain heavily underpatched, poorly segmented, and weakly monitored. We're talking about factories that are sometimes decades old, and for any kind of change to happen in those systems, you need to wait for maintenance shutdowns, either minor, major, whatever it is, but the turbines need to rest while you're fixing your SCADA segmentation. And this takes anything that takes days or weeks in IT can take years in OT. We are seeing a trend of more and more factories and producers being monitored. And again, we're seeing a surge in MDRs, SaaS, OT analytics that are coming out. We're seeing AI-powered anomaly detections. Someone asked me once, what's the difference between anomaly detection and AI-powered anomaly detection? I jokingly answered an additional 20% off the price. But today, when we're looking at anomaly detection, obviously AI is becoming a larger and larger part of that. Another thing that we're seeing is IEC 62443. We're seeing a little bit of ISO 27X coming in. NERC SIP, obviously big. And then on the other side of the Atlantic, we have NIS2, which needs to be localized, and then for each country, it needs to be regulated locally. Having that said, if you look at those standards, and I think I heard Maria ask a very good question in the last session. There are very, very smart people on the federal level, like the people who wrote FERC, NERC SIP, the people who write regulation, very smart, very well funded. But then you have the national, the federal level, then the state level, and then the municipal level, and then by the time it needs to trickle down to the owner operator, the guy with the boots on the ground. Very little of the knowledge actually makes it to the people who are supposed to implement that. One of the initiatives we're doing right now is we're trying to create a benchmark which connects NERC SIP, IC 2062443, NIS2 into one combined network that will serve as a common language for regulators, vendors, and owners, operators. It's part of what we need to do as a sector and as people who are promoting cybersecurity, especially in the energy sector. Again, zero trust, segmentation, this stuff is slowly, very slowly, but it is trickling down definitely to new power plants. We're seeing digitization, IT/OT convergence. This is something that churns my stomach when I say it. It's kind of a double-edged sword because most, or yeah, I'll say most of cybersecurity solutions are IT oriented. And when you see the new technology that comes out for OT, it's intrinsically built for IT. And what we're seeing, and I'll talk about it later when we talk about monitoring, is that the whole concept is, computers are computers, right? So let's do it. Let's do IT/OT convergence. And it's one of I don't know how many, but one of the deadly sins when you go and do OT cybersecurity. So going to our point, SOC and SIM, the struggle in trying to make the leap from IT to OT environments. Obviously, both technologies, both SOC and SIEM technologies are inherently IT oriented. They were born in IT, they serve IT, they have years, decades of experience with IT, and for OT, not so much. Part of it is that when we talk about decades-old infrastructure, we'll see legacy OT devices that either are very difficult to monitor, all through almost impossible to monitor. If we're talking about PLCs, if we're talking about anyone familiar with the Purdue model, so level 0, level 1 of devices, I'm not aware to this day of any solution that actually monitors those devices successfully, obviously. And then when we're looking at OT-aware SIEM platforms like Nozomi or IoT 365, Sega, again, they're IT-oriented, trying to do a decent job with OT, and that's not trivial at all. If you're looking at the actual SOC, the Security Operations Center, you have analysts that are looking at systems, usually IT systems. It's fairly easy, and I'll talk about that in a second. It's fairly easy to uniform monitoring to IT systems. Everyone has their version of Active Directory, their DCs, their printers, their servers. It kind of looks the same usually. There's a little bit of difference now with cloud hybrids, but the basic level is basically the same. And this is for IT, and I'll talk about OT in a second. So why am I so high-strung about the IT/OT convergence and the difficulties to monitor OT devices, OT shops, factories, plants, etc.? there's a story I like. There's this guy, it's the middle of the night, and he's under the street light looking for something. So his friend comes up and asks him, "What are you looking for?" The guy says, "I'm looking for my wallet." So the friend asks, "Did you lose your wallet here?" He says, "No, I lost it up the street." So the friend says, "Why are you looking for it over here?" The guy says, "Because we have light here." And when you think about monitoring OT and trying to do cybersecurity for OT, if you're using IT paradigms, you're just like this guy. And I'll expand in a bit. So when we look at anything that does any kind of modeling for the network, if we're looking at segmentation, if we're looking, I'll give you a quick example about segmentation. When we do segmentation for IT networks, we'll take relatively similar devices and we'll segment them out. So we'll take the servers, that's one. We'll take the DMZ, that's two. We'll take printers and scanners, that's three. And then each floor has its own PCs, that's five. Maybe we'll have our, I don't know, development segment, etc. When we're dealing with a power plant, or let's say a PV, a photovoltaic plant, if this is how you do segmentation, that's a bad idea. Why is it? The reason behind segmentation is that if you lost one segment, you can still go on with the others. So if you take, for instance, all PLCs and segment them out, and an attacker gets the PLCs, then the entire plant is down. Doesn't matter how many more segments you have. And that goes over to a lot of OT tech. So different types of segmentation, different types of cybersecurity measures and controls need to be taken in place. And obviously, same needs to go when you're doing monitoring. Again, when we talked about how we see an IT shop, IT shops are usually more or less the same. Your Active Directory is usually the same. The way you're doing your LDAPs, the way you're doing your I guess either segmentation or credential hardening, or whatever you do, it's usually either the same or by the same rules. When we look at energy facilities or water facilities or transportation, each facility is unique. And the reason that's happening is because once, and I'm comfortable with energy related examples, but once this huge turbine leaves Berlin and goes to Dubai, every client will have different a different, I would say, concept of how to secure their plant. They'll have different regulation. Obviously, we talked about three of those, but there are obviously a lot more. And the way they're built and the way that a lot of those systems are patched, not in the sense of how we patch our computers, but for instance, if you take a T3000 Siemens SCADA system, if you take that and you need to upgrade it, it's well into the seven figures. Only the upgrade. So when we go in and we do audits, a lot of the times we'll see old, XP stations where the power supply is just hanging by a little rusty thread or screw, and no one has either the capacity or the ability to replace them. And this makes every facility and almost every factory unique. And this is something new that we need to look at when we do monitoring. I talked a little bit about levels 2 and plus. I talked about the 0 and 1. 0 and 1, 0 would be the actuators and the sensors, and then level 1 would be the controllers, and then the 2 plus, level 2, which is the SCADA, and then 2.5 and 3 are levels where the systems are more Windows-based. So if you see the big guys monitoring, you'll see them usually monitoring those levels. Usually they'll do the Windows machines. Very few companies are actually looking to monitor those controllers and actuators and sensors, let alone the actual process, which is something that I'll also talk about in a second. So when you're monitoring today, you're basically monitoring the operational feed that comes out of the process and not the process itself. Lastly, when we talk about the process, in 2010, if I'm not mistaken, there was a cyber attack against the Natanz uranium enrichment facility. The attack, dubbed Stuxnet, what it did is it manipulated the controllers to do one thing, and then sent information to the HMI, to those monitoring screens, that everything's in the green and everything's fine. And while this is taking place, you see centrifuges just smoking up, shaking. The entire building is shaking, and the centrifuges are exploding, for lack of a better word. But when the analyst or controller is sitting by the HMI screens, they're seeing that everything's green. And when we're looking at monitoring solutions today, everyone's monitoring those HMI human-machine interfaces and not the actual centrifuge. This is caused by multiple reasons. One would be that we're talking about proprietary protocols. Some of them are encrypted. It's not a touch and go when you need to actually understand the actual process and how it relates to your SCADA system. So it's not trivial. It's a lot of work, and scaling this is, I haven't seen anyone do it yet. It's something that we're working at Marija Security. Hopefully in the next few months, we'll have something in the news about that. So having that said, when we're talking about proactive cybersecurity, obviously it has to start with the actual cybersecurity measures and controls for the environment. but monitoring is key. And this is, I hope I kind of revealed some of the difficulties in doing the leap from IT to OT. I will leave about 5 minutes for questions if anyone wants to communicate. Hopefully you see my email at the bottom of the screen.
Thank you, Joseph, for on-time conclusion for this talk. I think now let's have your Q&A, please, on the chat, for those who want to raise questions. Any questions that anybody would like to ask Joseph?
This happens either I was 100% clear or
we have a
0%
question.
clear.
We have a question for
Sure,
Dr.
yeah.
Dr. Jun, can you ask question, or do you think, let me see, allowed to talk? Okay, can you speak?
Yeah, so can you hear me?
Yes.
Okay, thank you. And I really want to ask, the question about, so in your talk, it's pretty much, just mentioned, the big requirement, the issues. Yes, that has been well described. But however, I really want to ask for the direction, the question about the direction. In order to solve, of the issues you have raised, what will be the suitable direction from your perspective? And so basically, a simple if I simplify my question, okay, to be that whether do you think that continuously patching the existing system will probably will work, or actually we have to design of really the new cryptographic solutions, and which will be easily get work made it to work on the limit the devices with limited resources. And also suppose if such new solution has been somehow in its early stage of having been developed, how to be able to go through of the painful of the standardization process and also certification process, because otherwise some of the result may will be forever locked in the lab. I hope I made my
Right.
clearly.
So thank you for the question, June. I think you didn't miss any toes to step on, which is perfect, and I mean it in the best of ways. So on one hand, we have very big factories that are using, like we said, decades old technology, and to upgrade that is extremely expensive. And then even if we somehow all agree that we only do security by design for the new equipment that comes out, so like the new H-class turbines that are coming out now, we'll all agree on some kind of concept that says, okay, everything that's coming out new, let's secure it by design. But then, like I said, we have US uses NERC-CIP, and the Europeans use NIS2. And for Europe, you have every country, you have its own localized kind of standard. And then you have India, and you have Asia, Southeast Asia, you have China, you have Russia. There are a lot of regulators around, and then there are multiple vendors. So each vendor has their own either concept or way of securing their system. And then you have the owners operators who are not very tech or cybersecurity savvy to have any kind of I would say, requests or demands from the vendor.
Thank you, Joseph. I think we are running out of time, 1:30 for next session. So I think if folks have questions, I think they can reach out to the email that you have, assaf@maya-security.com. I know that we had more questions, but we need to move on to other sessions. So appreciate Joseph for your time this afternoon with us. Sorry to appreciate it. We just want to be on time. Thank you. Okay.
Sure. Thank
So
you
let's
very
move
much.
on to the next question. Next session, please. Thank you, Joseph. Okay, the next session is setting the stage for long-term anticipation for infrastructure threats via collaborative research. This is an initiative led by George Mason University, UND, and University of Arkansas. And do we have Dr. Maxis here on the session?
It looks like he's currently
Yeah, I
backstage.
just moved him.
Is he there?
Yeah, I just moved him to the webinar.
Yeah, okay. Can you show the bio for Dr. Max so I can introduce him? Next slide, please. Okay, Dr. Massimiliano Albanese is a professor in the Department of Information Science and Technology at George Mason University. He serves as an associate director for Center for Secure Information Systems and associate chair for research of the Department of Information Sciences and Technology. Dr. Albanese received his PhD in computer science and engineering in 2005 from University of Naples Federico II and joined George Mason in 2011 after serving as a postdoctoral researcher at the University of Maryland, College Park. His research interests are in the area of information network security with particular emphasis on modeling and detection of cyber attacks, situation awareness, network hardening, moving target defense, configuration security, and vulnerability metrics. Dr. Albanese has participated in sponsored projects totaling $13 million with a personal share of $3.5 million. He holds 4 U.S. patents and co-authored 2 books and over 80 publications in peer-reviewed journals and conferences. He's also a recipient of 2014 Mason Emerging Research and Scholar Creator Award, one of the most prestigious honors at George Mason. He has served on the technical program committee for numerous conferences and a member of editorial board of IEEE Internet of Things Journal, Springer International Journal of Information Security, and Elsevier Computer Security. And then we have also, thank you, Dr. Max, for being here for this afternoon. We also have can you go to the next slide? I'm not going to read the whole thing, but I think we also have Dr. Chris Farnell from University of Arkansas. He's an assistant professor in electrical engineering and computer science at University of Arkansas. His research interests include cybersecurity of critical infrastructure, embedded system design, FPGA design, advanced control algorithms. He also, let's see, okay, where did I miss it? He's also serving as Associate Director for the National Center for Reliable Electric Power Transmission located at the University of Arkansas. This is a 12,000 square foot laboratory, provides equipment, technical staff, and instrumentation to test and evaluate power electronic circuits and systems at realistic industrial and distribution voltage levels up to 6 MVA power ratings. Chris is also current chair for IEEE OSAC section, treasurer for newly formed IEEE Computer Society, the Cyberhawks, registered organization of faculty mentor, and remains active in K-12 outreach activities. And then we have also another colleague from Kevin. Kevin, do you have the other bio for Kevin? Can you go to the next slide? We'll introduce all 3 speakers at one time so they don't have to. Dr. Kevin Jin is an associate professor in the same department. His PhD is from University of Illinois, Urbana-Champaign. His research also focuses on cybersecurity, networking, and CPS security. Dr. Jin and his team has received 6 Best Paper Awards from various conferences, notably IEEE Smart Grid Com, IET, Cyber Physical Systems, and so forth. And Dr. Jin is also recipient of the Air Force Office of Scientific Research Young Investigator Program Award. We can go back to Dr. Max, the previous introduction. You don't have to introduce me. People know, I think. Yeah, so Dr. Max, the floor is yours to talk about our
Okay.
efforts.
Thank you. I'm going to share my screen. Are you able to see my screen? No.
We see something.
No, okay, it's not what I meant to show. No, where's that?
Yes, we can see it. Yeah, go ahead.
Okay. So thanks, Prakash, for the nice introduction. Again, I'm Max Albanese. I'm a professor at GMU, and I've had the pleasure of working with Prakash and Kevin and Chris for the last year or so on this idea of creating this new center, which aspires to be a NSF IUCRC Industry University Collaborative Research Center. But as you know, for the past year, NSF has not been operating as normal. So as I will be describing through this presentation, our goal is to move forward to leverage the momentum, whether or not NSF is going to be, operating as usual. The name of the center is the Center for Infrastructure Security in the Era of AI. So it's primarily a cybersecurity center, but focused on infrastructure security and leveraging the rise in the use of AI, both for defensive purposes and offensive purposes. So the vision for this center is a world in which AI will integrate with defensive mechanisms embedded in different infrastructure systems. The idea is that we want to protect those infrastructure systems from threats that are being powered by AI, in addition to traditional threats. So we're going to use AI to understand those threats and to adapt our defenses to be on the same level playing field as our adversaries. When we talk about infrastructure, I'm sure you're all aware about the 16 sectors that have been defined by CISA, going from food and agriculture to energy, healthcare, transportation, and many more. Now, there is no question that the number, extent, and severity of attacks against our critical infrastructure is on the rise. And in this slide, I just listed a few notable incidents that happened in the last few years, but the list is much longer than that. From economic point of view, there is no need to argue too much that this is a serious problem with a significant impact on the economy of a state. The amount of damage, as shown by a IBM cost of data breach report, the cost of a typical incident on a critical infrastructure is more costly than other incidents that may happen in traditional infrastructure, traditional cyber infrastructure. And this is in part due to the interconnected nature of critical systems, the fact that there are both a cyber component and a physical component, with a failure in one propagating to the other and vice versa. So this is certainly a sector where there will be more investment in the future, and we want to leverage the momentum to both secure our nation infrastructure, but also to advance the science behind it. Now, I mentioned the NSF IUCRC, and I want to give a brief description of what it is. So this is a program that NSF has run for multiple decades. It's probably older than me. The idea is to bring together industry, academia, and government to solve problems of practical importance, with a practical impact. And this different entity contributes in different way. The government, which is NSF in this case, contributes funds to operate the centers. Industry partners contribute funds to advance research projects. And the university bring the talent and the expertise and the research capabilities to solve those problems. As of 2024, which is the most recent available IUCRC fact sheet, there were 79 IUCRCs across the nation covering 41 states and involving over 120 universities. And those universities brought on board over 700 different companies and organizations as members. One interesting aspect of IUCRC and one metric that NSF likes to track is the number of students who were trained through these centers and later got hired by one of the companies that are part of those centers. So the number they have for the statistics is about 1,200s, a little over 1,200s in the period going from 2015 to 2024. But this is clearly an underestimate because these are only the students for which they have data. There may be many more students who were trained in IUCRC who got hired for which we don't have information. Now, the way a typical IUCRC operates is the Industry Advisory Board decides what projects get funded with a pool of money that is being collected through membership fees. And faculty either pitch projects to the Industry Advisory Board, or the Industry Advisory Board explicitly requests faculty to work on specific problems. There are many benefits that are available to members who participate in this program. Of course, the most obvious benefit is access to faculty within not just one university, but multiple universities that are part of the center, in which, in this case, George Mason, University of North Dakota, and University of Arkansas. IUCRCs are also a way for companies to de-risk their research, because they can pilot projects within an IUCRC before taking larger risks. And in doing so, they have access to research facilities that are available across the different universities. Also, by pooling resources together, they can work on more ambitious projects that may be of interest to multiple companies and may solve bigger, larger problems. And last but not least, there is a very interesting agreement related to intellectual property. Members have access to the entire portfolio of intellectual property generated by a center, which in the long term could be a multi-million-dollar operation per year for very successful centers. And that all those benefits come for a very reasonable nominal membership fee. Of course, this is an NSF, so there are also benefits for the public or the community at large. And one of the main benefits that I've mentioned before is workforce development. NSF likes this center to be a way to train students, graduate students, PhD students. And in fact, students are highly involved in research projects. They are incentivized to be the ones presenting and pitching projects to industry, of course, in collaborations with their faculty mentors. And other benefits, societal benefits, is through this mechanism that brings together industry, academia, and government, at least on a semi-annual basis through IB meetings. Over the years, over the decades that this program is operated, there have been numerous lasting partnerships where smaller companies have been acquired by larger companies. There have been mergers and acquisitions. Smaller startups found the killer application by working with other bigger companies, and so on. Now, in terms of what research will happen in this center, of course, it will be driven by the needs of industry, and the directions will be dictated by the Industry Advisory Board. But we can encompass a wide spectrum of different areas of research, going from AI-enabled threat detection, AI-driven resiliency, data privacy, ethical AI, supply chain security, and many more. This slide is just to give you an example of potential projects that may be of interest to the center. And this was based on talking with different potential industry members. In fact, you will see different logos on this slide, which indicate which companies have expressed interest in which project. I'm not going to go into details of each one of those because these are just sample projects. As I mentioned before, the actual projects that will be run in an IUCRC are dictated by the needs of the industry members, and those needs may change over time to adapt to a changing world. In terms of the funding model, this is the standard funding model for IUCRCs, and then we'll get to what it means for us. The IUCRC program is a multi-stage program. There is a planning grant for those who have no prior experience running an IUCRC. That is a one-year grant, small grant. That is followed by a phase 1 grant, 5 years, $150,000 a year per site, per university. Which means if you have a 3-university center, NSF funds $450,000 a year. And then phase 2 is $100,000 a year per site. What is the expectation? The expectation is that universities will bring in industry members paying a membership fee such that the total of the membership fees matches the amount supported by NSF. There are several membership levels starting from what is called the associate level, associate membership, which is $25,000 a year. The full membership is $50K per year, and the members can go up to $100K in contributions. With respect to the benefits that I mentioned before, there is no difference, substantial difference between these membership levels. The main difference is in the voting power on the Industry Advisory Board. Full members have a full vote on the Industry Advisory Board. Associate members have half of a vote. Members who pay $100K have 2 votes. No member can get beyond 2 votes. Members are allowed to contribute more than $100K, but they will not buy more than 2 votes beyond more than 2 votes. And this is done to prevent that a single company may have too much of an influence on the center. Now, how is the money used? The money provided by NSF is used for administrative purposes to operate the center. The money collected through membership fees is used for project, and it's allocated by the Industry Advisory Board. The university have no control on their money. It's allocated based on decisions on the Industry Advisory Board, and that's where the voting power matters, because the Industry Advisory Board will decide how to spend that money. One interesting thing about the IUCRC model is that NSF limits the indirect that can be charged on industry memberships to 10%. The reason being they're already contributing to the administration of the center. So essentially, $9 out of 10 go to actual research. What's the current status of our center? The University of North Dakota and University of Arkansas received last year a planning grant and completed all the planning activities by now. We at George Mason did not apply for a planning grant because we received a waiver since I was already involved in another IUCRC. So we skipped that. The plan is to apply for NSF funding as soon as NSF releases a new solicitation. The previous existing solicitation is being withdrawn for the time being. It was supposed to be released sometime this fall semester, but as you know, the government has been shut down and everything is delayed indefinitely. As part of the planning activities, we had a very successful planning meeting in Arkansas in February. And in the interim, while we wait for NSF to release a new solicitation, we don't want to lose the momentum. So we have decided to move forward with creating the center, irrespective of what happens with the government or NSF in particular. So at George Mason University, we have established the center as a center under the College of Engineering and Computing. So we are ready to launch it. And actually, there is a big event that we're organizing in December. It's called the IDIA Industry Day. And as part of that event, I plan to officially launch the center and start recruiting members. On that, related to that, I also want to mention, it was not in my bio because it's a recent thing. But since the beginning of this semester, I've been in a new role as executive director of one of the 3 university level institutes, the Institute for Digital Innovation, or IDIA. And as part of this role, I'm organizing this industry day. Among other activities that will happen that day is the launch of this center. That said, this is a quick snapshot from the planning event that we had in Arkansas in February. There were over 60 attendees. All 3 universities were represented, I including myself. 15 faculty, over 10 students, about 20 potential industry partners, 3 national labs were represented, and 4 government agencies. So it was a very successful meeting. A lot of interesting discussion came out of this. And now we are ready to leverage the momentum and spring into action. And with that, I'll open it for question and or for Kevin and Chris and Prakash to add anything they would like to add.
Sure. Thank you, Max, for your leadership on this. I think, yeah, why don't we have Q&A while we continue to speak? And if there's questions, please feel free to put them on Q&A. This is a consortium effort that the 3 universities are doing, and Max has been great to work with, and he's been putting a lot of his time on this and energy. So if you're a company listening to this, and this is an opportunity for you to get involved in collaboration, or working on white papers, doing different things, in becoming a member, or even at an affiliate member for to get things started. At UND, we have a number of DOE Caesar critical infrastructure projects going on. Actually 3 active projects. One of them is physical hardening of substations against gunshots. From time to time, we have a lot of gunshots happening in the substations, and DOE gave us this funding for UND in partnership with local power company, Minnesota Power, and Grand Forks Sheriff Department to classify malicious versus non-malicious gunshots. And it's a very good example between partnership with Colorado State and University of Wyoming, who are also part of this project, focusing on hardening critical infrastructure. And we also have another project that Argonne National Lab is going to present this afternoon. It's all about Edge AI using for DERs, so how we can model different cyber attacks at the DER level, how we can protect them against cool AI and machine learning approaches. Siby from ANL is going to share some insight this afternoon with you. We also have another new award from DOE Grid Air from University of Maine, which is in incoming funding on focusing on self-healing capabilities of electric vehicles. So there are a number of efforts that UND is involved on as part of the center. Chris, do you want to say a few things? Or Kevin, what's going on Arkansas side?
Yeah, just real quick, and then I'll pass it over to Kevin. We did have our planning meeting, as Max had mentioned previously. It was great. We got a lot of industry engagement, lots of utility companies, lots of design companies and such coming, thinking this is a very timely effort. And we are pressing forward with various other collaborations with our partner institutions as well. And everyone here is very excited to see this happen. Kevin, did you have anything else you'd like to say on that?
Yeah, I think you summarized pretty well. And I want to add on that is we're also doing lots of workforce development here. For example, like Dr. Chris Farnell, like last week, he had a radar hack event over the weekends that INL come to us and give some good tutorials. And there are lots of interesting things going on here as well, not only for research, but also for workforce development.
Okay, cool. Matt, when is that event at GMU? Is it something open for everybody to attend, or what venue, or is it something?
So the event at GMU is on December 2nd. It's open to anyone. It's free, but it's only in person.
It's all in person. Okay.
Yeah.
Okay. Sounds good. Any questions from the audience about the initiative?
So anyone who happens to be in DC that week, is the week after Thanksgiving, you're welcome to join us. And so far we have over 90 people registered. And there are still a few new, mailing lists going out this week to different groups. We were able to bring the president of the university to speak as a keynote during lunch, and we're trying to bring in a congressman. So we have the folks who are in charge of government relationships for Mason. We're trying to bring in a congressman to the event.
Cool. And just for the audience, this is the only NSF-funded IUCRC forum focusing on critical infrastructure. The way this acronym is remembered is ICAI. I had a hard time to remember this, but I think Max has taught me how to remember this, ICAI. So, if you have any questions, on how to get involved, please reach out to Max or me, and we can see how we can collaborate on this effort. With that, thank you, Dr. Max, for your time this afternoon. Let's move on to the special. And thank you for Chris and Kevin for joining. And let's move on to the next session. I know we're 5 minutes early, but I think is Dr. Marija is here. Dr. Marija, are you there?
Yes, I am. Yeah.
Oh, okay. I just want to make sure that you're there. So can we
No,
start?
I'm here. I was just trying. Okay.
Okay, I'll introduce you.
Don't have to read, please. Just
I'll try my best.
Let me say myself, I've been around for a long time and getting older, all that. So, and I'm at MIT now. You can just look at the website and don't waste time on that. I'm okay.
Yeah, sounds good. Go ahead.
I will use my time to talk.
Sounds good. The title for this talk is Boosting Cyber and Physical Resilience for Energy Dynamics in Power Electronics Dominated Grids. Thank you, Dr. Marija, for being here for this workshop. And
Sure.
Go ahead.
Let me see if I can share my stuff here. Just a second.
How do I say your name, just for my own?
If you really want to pronounce it the correct way, like even I don't pronounce anymore, it's Marija, but it's
Marija.
But it's Marija. Everybody is knowing me as Marija, so that's okay. Only my husband calls me Marija, so he still remembers the.
Okay.
Anyway, so it's like Marija without J. Yeah. Okay. So thank you very much for inviting me the last minute. I guess I got on this, so I prepared, but I have to say that I was listening very carefully today, in particular to early talks, and I think that the burden of proof is on all of us is pretty heavy. I just heard about a lot of open questions. I'm trying to put in context what I'm going to be talking about, in context a little bit of those questions, and I'll refer to it once in a while for that. So one thing I heard early on is that from whichever side one looks, there is no protocols or there are no processes for information sharing, for cybersecure information sharing, and basically no protocols for connecting the dots, as people were talking about that earlier. So the title of this is specific to power electronics dominated grids, but is applicable to also to just conventional power plants, grids. And the idea is it's joint work reporting on one past project that Texas A&M, Dr. Lushi led, was funded by SETO, the U.S. Department of Energy, and there is a relatively, a significant project led now by San Diego State University by the young professor Tong Huang, who is PI, and then I'm co-PI from MIT side. And we have one graduate student, Miroslav Kosanic, who is advanced grad student funded on that. So basically, the question is how to integrate really cyber and control in a secure way, because people were talking quite a bit about OT and IT and them not working together. So I think I'm coming at it from a little bit different corner, but I will try to connect with what has been talked about today. So particularly intriguing, I found the comment from Maya person, from Joseph, I believe, on how IT is so much easier to certify because you have similar components. In power systems, we have very heterogeneous components. So the question is, how do we go from complexity to something that's manageable? And so it goes without saying that that still remains an open problem. So I organized a talk first. It was mentioned again earlier that the key role for the complex systems like power systems to work in a secure way, there is a key role for grid edge resources. You cannot do it all in a top-down way. And so I try to relate that comment to what we've been doing. We've been actually rethinking the grid as an interacting system of many microgrids, different subsystems, different entities, how would we enable such grid to be cyber secure by next generation SCADA? So that is what I'm concentrating on. I'll take just a few examples on how power electronics fits into that, into lower, medium voltage, low voltage grids. But from whichever side one looks at it, the problem is very complex and system remains vulnerable to cyber attacks. So to manage this complexity, in particular, the operations, in particular control, what we are and monitoring, control, monitoring, communications. We introduced early on this view. It's been going on now for 15 years. This idea of we have to move from the today's SCADA to next generation SCADA, which is more end-to-end, and we refer to that as DIMOS, Dynamic Monitor and Decision System. So I'll talk a little bit about that, but the whole idea is then that if we model the system, if we rethink the modeling of the system that we use for operations, for control, it is very detailed, technology specific at different levels and so forth. So we have now worked for quite some time, not in context necessarily of cybersecurity, but for more reliable and efficient operations of changing systems by introducing aggregate level model of energy dynamics rather than just very detailed dynamic models that one has for different heterogeneous components internally. So basically, if one has that model, then the structure, one can reveal the structure which helps embedding cybersecurity into the same model. And so one can begin to align operations, OT, and IT. And I'll talk about that some more. So this is just basically what I want to cover. But the main point is that this structure leads to distributed, zoomed in, interactive, and zoom out unified specifications. So doesn't matter that technologies are heterogeneous, it provides the basis for systematic control. And then we have, in this project that I mentioned, extended it to cybersecure framework based on the same modeling. So the main point that I want to make through the talk is that zoomed out system level information exchange does not require internal zoomed in details. This is one thing to remember. These are only needed when designing specific components and their automation and their cyber and testing their own cyber secure logic. distributed cybersecure logic, but when one comes to the system designer doesn't have to know everything, and that really simplifies quite a bit on what needs to be exchanged and what needs to be monitored and controlled. And at the end, I will mention just some examples, if we don't run out of time, what Texas A&M and San Diego State and we have been doing. The interesting thing is the one, if I don't get to it, that Texas A&M has actually done case study using real data on a very large center point microgrid and demonstrated the framework that we are talking about here. So to start with, I mentioned that the basic idea is that we really need to rethink the grid as interacting microgrids, which are enabled by cybersecure next generation SCADA. If one looks at these, can you see my pointer?
Yes, yes.
Okay. So if one looks at this sketch here, this is basically the sketch of Eastern interconnection, Western interconnection, in which we have many balancing authorities. We call them smart balancing authorities, and they're all interdependent. However, what has changed is that inside every balancing authority, we have many other actors, different stakeholders with their own objectives, and they have a lot of intelligence themselves. We refer to them intelligent balancing authorities. So everybody processes that something for operational reasons, for financial reasons, but they all coexist. And actually, when one looks at it from the cybersecurity point of view, malfunctioning in one subsystem within this nested network architecture could create malfunctioning in the neighbors and sort of bring the whole system down. So given this changing organizational industry structure because of unbundling, it is no longer possible to consider these individual balancing authorities or microgrids by themselves. They are physically interacting, and also, as I said, malfunctioning can affect everybody. And what we've been doing, we've been working on modeling such what we refer to nested network architecture, in which if you just zoom into one balancing authority, there is also inside other balancing authority stakeholders, and they interact. And to connect with what was talked about this morning, the real problem with these systems is, I list here on the slide, and I'm not going to go through details because this was more for modeling purposes, for control purposes, decision tools that we really still don't have even for operations at different system layers. But for the purpose of what we are talking about today, the real problem is lack of protocols for information exchange, understanding for what purpose, so that the system as a whole does something. I also should mention that if one goes into physics of these systems, the temporal interdependencies are very complex, because here you show solar goes and then comes down. We have these duck curves in California. So predicting demand and scheduling things on the system so that everything works is become much more complicated for two reasons. One reason is this temporal intertwining, that you cannot assume that something settles and then think about stability. They all affect each other. And the second one is nested architecture. What are the objectives of different subsystems in this system? Okay, so just a few examples of what we are talking about. So in the SDSU project, Professor Tong Huang and Chris Mi are working on power electronics dominated distribution grids. And here are some examples what they look like. You have the conversion from AC to DC if the households have DC loads. And so there is a lot of power electronics embedded in lower voltage level, medium voltage levels. Deep penetration of these, what's known as IBRs. And these systems can be exposed either to very large physical disturbances when you don't know how to operate them now anymore, but also to cyber attacks. So the general question that we were studying in this project was how to design distributed monitoring and control systems that enhance cyber physical resilience. Once more, to emphasize what we were talking about today, it's not all top-down one way. And I'll elaborate on that some more. So it's distributed and interactive. And one can look even further into cybersecure operation for smaller microgrids with a lot of solar PVs, and you still see the same problems. There are challenges because you don't have accurate models, things are time varying, solar is intermittent, but it's also very hard to detect unreliable attacks and so forth. So the overall goal that we've been studying is because corruption of the, if sensors and communication path attacks can corrupt the feedback control loop. In a lot of these things have their own automation primary control. So really being vulnerable because feedback control does something wrong, and then the system goes unstable or gets burned. And so the idea is to develop an end-to-end cybersecure monitoring and safe operation framework that ensure real-time cyber attack detection and safe operation. It is actually mouthful, but that's what it is. I want to also mention that these are not just power electronic systems. If you have at the bulk power system level, we see more and more. I've sketched here, and I don't want to go into mathematics, but there are two areas with some generators loads inside. These are balancing authorities, and they're interconnected. If you look at dynamics because of uncertainties or because of these IBR resources, there is more and more inter-area dynamics between them. So they are not as stationary. You cannot just predict what the area controller is and schedule your own thing. You are actually affected by the others. And so the bulk power systems have the same challenge of how do you operate them and stabilize them in a cyber-secure way. Okay, so what we've been doing is, I mentioned these end-to-end dynamic monitor decision systems, which we believe that could be the basis for next generation SCADA. And what it looks like, the easiest way to explain is, remember there were nested balancing authorities and a lot of intelligent balancing authority inside them. So make different subsystems all intelligent. They process their own control objectives in a distributed way. They do their own, even sometimes grid edge locations, cybersecurity, and they have to still exist, coexist as one interconnected system. So these blue dotted lines are basically just, if this is a control center at the bulk power system level, this is just communications that comes from the bulk control center down to substations. And there is no more. What we are proposing is that you have to really have some situational awareness and information exchange and actions for cybersecurity, for control, for this system to really work under many different conditions, all the way down to small users, and also the information exchange should be interactive. So we have spent, I would say, 10 years, and maybe on next slide there are some references which you can look into. I don't have time to ask just one simple question. What is the minimal information that needs to be exchanged between different layers, in which the subsystems have their own dynamic monitor decision system? They're intelligent themselves, and they do something, but in order for the system to coexist, it's a very complex system. They still have to have some binding information on their specifications, if they met their standards and so forth. So it took us 10 years, and I really don't have time to go through that, but it's actually fascinating, simple result that minimal information has to be in terms of expected energy that comes or is consumed by particular subsystem, and the rate of change of both real and reactive power. That's it. So triplet, and we call those interaction variables. Interaction variable between particular subsystem that you zoom in and the rest of the world. That is sufficient to, we are basing a lot of, even the course I teach, graduate level courses, saying, okay, how do I rethink these interactions within the system in a straightforward way without requiring students to know all the technological details about how is energy conversion done, how is it controlled internally. We've shown that in order for to check if the system is feasible, reliable, secure, you just need to have exchange, feed forward information about these three variables rather than ask what I think people like to ask engineers to still know what is inside every solar or SST and so forth. That's just not doable. Vendors are not going to share. But this was a very encouraging result, which now, once we have these theoretical results, you can now base the next generation SCADA to support this information exchange among different IBAs without, looking what's inside. So it's a standardized information exchange between neighboring layers, and that enables efficient markets and secure operation. That's the basic idea on diamonds. Now we talked about lack of protocols. If you just map what I just said here into what it would mean for cybersecure protocols, it would mean that each vendor, each subsystem, as we talked before, is responsible for checking its own internal security, but it would exchange this information that I mentioned in terms of energy, power, and rate of change of reactive power, which is not sufficient information for the intruder to come in and know exactly what's happening in that component. So this becomes a basis for simple protocols that work, and I gave some references here. They work so that because you go from complexity to requiring the minimum that's needed and allowing different intelligence to be embedded in different layers into grid edge all the way to substations to higher voltage levels, and then interacting. And I don't have much time to go through mathematics of these, but the key idea is it's like something like this. You have multifunctional specifications which are based on this unified energy-based modeling of dynamics. So if I have the entire system and I look at subsystems, I zoom out, then I'm just interested in these interactions, which are these specifications in terms of energy, power, and rate of change of power. Rate of change of power is extremely important in these power electronics systems. Or I can zoom in inside particular nested balancing authority, get different levels of different information about interactions between supply and demand, for example, internally, but I don't have to know what's inside these circles or inside the load. So once we started thinking this way, and it's been taking like very long time before I even started working with SDSU and Texas A&M on applying this concept to cybersecurity, what becomes really interesting is that these interactions, this is what power systems are about. They're about balancing power, rate of change of power, and additional, theoretical thing that took us forever because of voltages, also rate of change of reactive power. They all are sort of linear constraints on power. And so you, at the higher level, now you can have You can have even multi-energy systems when you have one of these blurs is gas, another hydrogen, water, and they all have common specifications by analogies in terms of energy and power. And so this is the fundamental idea behind having interactive model of interconnected systems. And you have multi-layered complexity. You don't have to model or know all this data. You just need to know this minimal information. I just put here so people don't think this is just a story. There is a lot of, I have at least 3 references here for people who want to read. But basically, we have the entire mathematics which says, okay, I go from these very complex technology-specific components, subsystems, which have their own states, their own internal automation, and they interact through power with rest. I go into this higher level model, which is energy space model, where everything, this is unified. Everything that you need to know about them is energy that it would store, power exchange, and rate of change of reactive power. Those are the interaction variables. The mathematics, all of that, no time to go through it, but there has been a lot of work in our group, both at CMU and at MIT. So how does this help now with cybersecurity? This is what I really wanted to share with you, because once the concept, like Professor Tong, he was a postdoc with us from Texas A&M, he basically came and said, okay, can we work on this set of projects to see how do we establish, how do we go and manage this complex system for cybersecurity. This is how these 2 projects that I mentioned started. So before we go into what was done under those projects, it's important really to note that you are going from complex and vulnerable, because if it's flat, if it's all top down, as we talked the whole morning, there is nothing you can do, to zoomed in and zoomed out cybersecure dynamic systems. So there's just this information exchange. Modules can be in different sizes depending on, how different components aggregate themselves. And so the whole cybersecurity problem now becomes the one of, you can even think about one of these blurs at grid edge subsystem, which based on its own internal information will check what is the, if the information outside, let's say the tie line flow exchange between the areas, is if somebody measures and corrupts that information about tie line flow between this module and the rest of the components, then you can internally compute what that exchange is and raise the red flag bottom up and say, look, I'm corrupted, I'm getting out. So that was the application to cyber. That's the basic idea when I started working with these colleagues. And it can be applied, again, I'm running out of time, but I can just leave this slide that you can now do cooperation, and a lot of stuff that was done, and there are some references there, is if you have, for example, different microgrids that are connected over wide area networks, if one does its own, we call them micro AGC because it's micro frequency regulation. But by that microgrid and the other, if one gets corrupted through this information exchange, minimal information exchange, the other one detects the corruption and helps. So you can do cooperation. And a lot of work that we did on that evolves around that, and I've given the references. So basically, 2 network microgrids can cooperatively help each other if one of them is attacked, where one serves as a temporary frequency regulator. So we have to move through cooperation for cybersecurity rather than all top-down or competitive. This is just an example of how we network the 2. And again, I ran out of time. I want to leave a little time just for some questions. But we did this. You can look at these references. Jayson Kim, who was postdoc from Texas A&M working with us here, applied this energy concept to do end-to-end cybersecure monitoring and safe operation framework with testing it all with real data on Centerpoint microgrid. That was a major work that he did and collaborated with engineers there, and it's reported in the paper that I gave you. So one of our PhD students, Miroslav Kosanic, is now working at MIT on, if you have these microgrids and they're all working in distributed way, everybody's trying to do their, let's say, frequency regulation, they want to help each other. But if delays in communications are either interrupted or the delays are too large, then this will not work. So you can establish, using this energy dynamics model, you can establish the bounds on what is the worst delay so that they can still cooperate. And for example, that communication can be destroyed by malicious attack, or is just the delay. So this is a PhD thesis that's coming close to its conclusion. You can put theoretical bounds on what is the slowest that you have to exchange information with neighbors in order to stay together. And just to mention one final thing, I'm personally very excited about this. We are developing this digital twin, which basically is emulating, using a lot of mathematical models with the structure that I mentioned, where you model ISOs, and you can do it for markets, but they all these nodes or the subsystems they have their own embedded intelligence and information. What I find very intriguing is that physical, communications, cyber, they all align using this energy space, and everybody understands each other because everybody understands energy and price. So, so this is work in progress, but it is an example. It is a facility. We'll have I think I mentioned here. It will have, towards the end of December, we'll have an open house. Probably it's going to be remote to share with people what this digital twin does. So let me stop here. Thank you.
Thank you, Professor Marija. I think very fascinating collaborative work, what you shared. So now we open for Q&A. Folks who have questions, please put forth the questions. Maybe I'll start with one question. I think
please go ahead. Yeah.
It's interesting that what you mentioned about for all these subsystems to coexist, your study focused on, what is a minimal information exchange that they need to do, right? You talked about energy, reactive power, and so forth, right? Interesting, we're still talking in this day and age to see, because this is an important question, right? And
it took us 10 years, Prakash. to actually have, and I can share with people if anybody is interested. I'll send more references, but the sort of breakthrough thesis was by Rupamati Jadivada, who graduated like 3-4 years ago as MIT. So you can theoretically prove that you're working with power systems. So imagine, I don't know all the fuel cells, I don't know all the SST, but I can think about interfaces in terms of specifications when the components are tested for either control and or security. And then when I put them together, I asked this question earlier, when you put components together, there is a problem, they may not work together. In this energy space now, you can test the condition under which you will still have power flow solution, they'll work together. And that's simple in energy dynamics. I'm sorry, I interrupted, but
no, I think I was just about to ask, the question was, now AI is getting a lot of attention. Do you see there could be more parameters that could be useful that you missed out, could be useful and actually, in the information exchange process of the different layers? Is that something that your team is considering more extending this work in terms of nowadays people talk about all physics-informed models, or different layers. When we talk about DOMs, we have multiple layers, 5 layers across from edged and microgrids, ISOs and whatnot, right? So I'm just curious. The question to you is, Do you think what is the role for AI in addressing the multi-layer complexity?
Oh,
Is more
it's huge actually, because you know I can draw these figures and equations till I go blue, but I need to verify these models with the measurements. I have to have historic data. I have to do the predictions based on what I've learned about the system. And so I think this becomes very real as we collect data and process data and get the patterns. We were restricting ourselves, so these interaction variables, they have to be exchanged in a feed-forward way, let's say for stability, very short time ahead of time, for scheduling longer term. But we believe, just based on whatever we have theoretically, that that's enough. But verifying this energy state space model, we did that, I didn't mention, but we had a project on the fourth largest airport airport in China, on the energy center in the airport, and they gave us all the data. But all the measurements are really just on interfaces of chillers, on this and that. You cannot look inside. So the fascinating thing is now you can, and the same thing happened with this center point project that Jayson worked on. You know, you cannot go inside the solar PV, you just can measure on the outside. So what can you do with that information? And that's one thing. The other thing that was, to me, is like AGC, you know, you can internally control yourself, you can internally check if you are cyber secure against the information that comes from the outside without having to simulate the whole system. So I think the time has come probably in power systems for data-enabled automation and things people were talking about for cybersecurity, because it's just too complex otherwise, and data will help us. So
yeah, that's why hopefully we can bring more and more utility, the conservative utilities on board to convince to deploy these AI-driven solutions. You know, we'll see.
So I think that I was very open this morning when I asked about standards, 1547 and so forth. There is no guarantee that when you meet those standards that the system will work. Now, when you go into this energy space, and we don't have time to do the lot of discussion now, but then you have provable conditions under which you can do, how much delay, what information needs to be exchanged and stuff like that, so that we have some confidence. So let me stop here, I guess.
Oh, Ginger, you're there. Do you have anything else to add, or?
I really am in love with the tenor and the pace of this conversation, that we move cleanly between deep research that allows us to push the boundaries, and then operational insights that allow us to understand what people are struggling with now and how the research may apply. So Marcia, thank you for pulling that conversation forward.
I think it's, we have to do it basically, right? Taking a step back with students and so forth and doing it, and with the industry. I was very impressed, and I learned a lot this morning from the industry, you know, just sort of confirming that we really have to rethink this thing. So thank you.
Thank you. I think we're going to move on to the next session. Thank you, Professor Marija from MIT. Appreciate your time and your team for sharing your information, research. Let's move on to the next session. We have Charley Cunningham. Hi, Charley. How are you?
Good afternoon, Prakash. Good afternoon.
Yeah, this session is operational resilience, lessons from the front lines of critical infrastructure entities. Charley Cunningham from City of Sacramento. Charley brings over 30 years of experience in industrial controls and automation, including more than 20 years dedicated to the water sector. He's a Utilities Operations and Maintenance Division Manager with the City of Sacramento's Department of Utilities. He oversees the electrical instrumentation and SCADA automation section, supporting critical drinking water and wastewater infrastructure. The Department of Utilities operates 2 surface water treatment plants with a combined capacity of 170 MGD, along with 14 distribution reservoirs and 27 potable wells. The wastewater system is one of only 4 large combined wastewater systems on the West Coast, and includes the operation and maintenance of 2 primary wastewater treatment plants. In total, the division maintains more than 180 pump and lift stations across the system. Over the past decade, the department has completed several major upgrades to its SCADA system, with cybersecurity serving as a key driver from network architecture to application layer design, enabling secure integration of nearly 150,000 data points throughout the operational environment. Charley brings over 30 years of experience in digital controls and automation, including 20 years to the water sector. Charley, it's a great honor to have you as part of this summit. I appreciate you devoting the time with us. Thank you, Ginger, for recommending Charley for the summit. Appreciate it. Charley, you have almost 1 hour, 45 minutes to talk about and share. We're going to learn from you, and we will reserve the last 15 minutes for Q&A, and I'm sure there's going to be a lot of questions for you.
Thank you, Prakash. And sorry for the duplication there on the bio.
No worries, yeah.
But,
do you have
yeah,
slides, or are you going to talk? What is the plan?
I do have some slides.
Great.
So
Okay, so can you share your screen?
go with the screen here. So can you see the slide there?
It's coming. Looks like I don't see it yet. Uh-oh, what happened? Tanzim, can you try share again?
Sure.
Is it allowing you to share?
Oh, there we go.
Oh, yeah, okay.
You see now?
Yes, we can. It's not in full screen though.
Yeah,
can you go to the display setting, and I'll make it like a the other option. Can you go to the second tab, display setting, and click on, yeah, maybe that one or the other one, the other option. Oh yeah, this is good. Yes.
Good? Okay.
Yes, thank you.
Sorry about that. So yeah, just wanted to share with you our journey to gain operational resilience in our SCADA system. As everybody talks about knowing your environment, that's so important in cyber, as far as knowing what should be talking, like just what we just were able to hear a lot of that in-depth research that's happening, and that's very exciting to hear from everybody today. But the network is part of it, right? As far as what our environment is, we had to realize that the skill level of our staff is very important part of our environment, and that people are actually trained to respond, and what that skill level is if we need to reach outside to where we have some additional support from contractors and sometimes other agencies. And then also another part of maintaining our resilience is identifying our critical spare parts and what do we have on hand. As mentioned in the bio, there's a lot of assets that we maintain. So there's over 200 facilities. It's water, wastewater, storm, combined system. We have 2 primary treatment plants. So we're looking at an atmospheric river forecast for beginning overnight and into tomorrow right now. And so in those conditions, there's 17 square miles of our downtown area of the city of Sacramento that all the drainage comes into the sewer system. And then all of that sewage has to be treated as sewer. And so we're permitted with the state water resources that we do primary treatment when we reach capacity with the level that we have an agreement to send to our regional treatment plant. Then we do primary on our side, and then we're maintaining those systems as well. There are the 2 surface water drinking plants. There's 18 wells, 12 reservoirs, the 9 wholesale water interties that are on the water side. Then that 175 sewer lift stations, and then we have within this that makes up that system, there's all the PLCs, our servers, domain controllers, the endpoints as we mentioned, and now we have perimeter protection on that equipment. And so with all of these assets that I mentioned, there are 2 supervisors and there are 7 specialists that we own all of it as far as the Department of Utility Assets. So that means the fiber, the the servers, the storage, our replication software, all of that is maintained. Those assets are maintained by our staff in DOU. We have a great working relationship with our IT partners that maintain and support the enterprise side of the house. So all of our, timesheet applications, work order applications, email. We don't have any email that rides on our process controls network. It's strictly process driven. There are some security applications that we have on there for our access control, which is where we badge in and out of the different facilities, different campuses throughout the system. And then there's some cameras also that are on that network. And that's just because we do not have other infrastructure in some of the places that we need those applications to run. But all the fiber is dedicated. We don't share strands with any other group. We have, our licensed wireless. So we have some microwave bridges. We also have some 900 megahertz radios that are communicating, and then some 4.9 for some of that larger bandwidth where we need the video. But for the most part, the relationship that we have with our IT is that we share insurance, we share contracts, and that's been fantastic to have the communication and collaboration with that group. But as far as supporting our assets, that's all done within the utilities process control group. So our standards and specifications were an area that we identified as being weak and needing improvement some time ago. This has been going back now, working on it for about the past 5 to 6 years. But we had an initial workshop that was a presentation on the cyber informed engineering from INL, and we started looking at where we had gaps in the standards. And so we looked at all of the standards that were related to anything touching the process control system. So the electrical instrumentation, if we had mechanical devices that were monitoring vibration, but those are also connected to our network. And all of those, we wanted to do this approach that we applied these concepts and updating those standards. And so we are constantly reviewing the standards. We develop standards for how our function blocks, right, and the PLCs are configured, the HMI widgets, all that rides on the human machine interface software, that we have some standards that if it does go out to contract, then we know what the product that we're going to get back and that infrastructure that's coming back for us to operate and maintain will be to our standard. And that's a lot easier said than done, because there's constantly development projects that happen where developers are hiring a contractor that they just did a job somewhere else and they have this canned program. And so it takes a lot of, having those standards in there that we give our inspectors and the folks that are reviewing those submittals something to go on, right? That we've already communicated that standard prior to somebody bidding this project. And so that's what our expectation is. And we've made that clear. And then through the project, we have to continue to have folks that are vigilant about upholding that standard. Otherwise, it'll be value engineered out at one phase of the project, or somebody's going to do an acceptance test on something that is not to the standard. And then the burden is on our team to go fix that once it's been handed over. And we try to avoid that because that's an expense to our ratepayers, right? That shouldn't be, right? If these standards are being upheld through the project, then we know that we have consistency. We also, looked at our network architecture. So when I first started managing the group, I was kind of told, well, we're good. We're air gapped. But we had this flat network that really wasn't, where we could update it. There's tons of legacy equipment. As far as, we have stuff that we've annexed in. The city has some of the pump stations were, a different agency and, installed 50 years ago. We try to upgrade those where we can. In California, we have what's called Prop 218, which means if you collect a fee for providing a service, then those fees can only go to that service. Your mayor cannot go, do a pet project or buy fire trucks with your water money. But that also means that on our drainage fee, that requires a vote of the public. The wastewater and water, it's a vote of the council, but the drainage fee is a vote of the public. And we haven't had an increase on our drainage fee since 1997. So there's a lot of challenges there because we cannot fix water assets with drainage or drainage assets with water money or vice versa. So those are things where we have to get creative. We have to look for solutions that will allow us to be as cost effective as possible. But due to the geographic layout of our system, that there's a lot of places where we share network because there might be a well on a regional PLC that's communicating back, and there's also a turnout. There's also a lift station. There's also a drainage station. So we have to keep track of all those assets and how those costs are shared. And we have a cost split, based on our tag count is kind of how we do it. But then looking at the staff for training and development, and not just our technical staff that's working on these devices, but also our engineering staff to kind of educate everybody as to, here's the direction we need to be going to limit our risk and improve, our network. So we had the previous work that was done this was prior to CISA. So it was with Department of Homeland Security. There was folks from INL that came out, conducted an assessment of our system. And then, that was where it was kind of the eye opener for the folks that thought, hey, we're air gapped and we're good. And we started seeing the vulnerabilities there of not being able to, update systems. One of the things that we've learned is that, we were moving toward everything being, an Ethernet protocol, but and also developing those standards, because we would have a contractor that they would go and they would program every parameter, right, to be talking over our network and bringing back data. And a lot of that was just clutter. It wasn't useful. So in developing those standards, it's like, now here's the parameters that we want to see. And then, as I mentioned, some of the legacy equipment that we have, there were, we also have standby power systems throughout the city for emergency standby power. And some of those engine controllers, right, the folks needed a way to communicate with them over some legacy stuff. They weren't on the same standard as we were doing with the SCADA system. So we found ways to where if we don't need to connect that, if we can just bring back some 485 or some analog inputs back to our SCADA system, and that tells us what we need from that device, then that's how we do that. And so that we don't have everything connected that necessarily may not have a need to be connected, and then just piling up data that nobody's ever going to look at. So that's a big thing that we've looked at is, also in the staff development, that we've had some, day without SCADA exercises to where if the system goes down, how will we continue to provide, those core services, and what manual controls, right, that potentially have been lost over improvement projects over the years, when there was that, thought in the mind that everything needed to be automated, everything needed to be on the network. Now we've went back in some locations, we've put manual controls in place so that if all else fails, we can still operate and deliver water to the city. We have an SOP. So one example. So there's a lot of standard operating procedures that go with this training so that staff can exercise, right? And then they can go and follow the procedure, become proficient at the procedure, so that if something does happen, right, it's not the first time they're ever opening that binder. So the example of one of the SOPs that was developed from our Day Without SCADA training was the ability to backwash a filter. And so we have multiple levels with multiple valves on our filters in the water plants. And it takes 9 staff people to be at all the different locations to do everything in sequence, but we can do it. So that's just kind of illustrates also the benefit of our automation and the value of our SCADA system, of how we reduce, the labor. But having those backups in place is very key for us to maintain our resiliency. So we've also done some self-assessments over the years with the American Water Works Association on their cyber assessment tool. And that's really good for staff to go through that, because then they are able to see, here's things we should be paying attention to, right? And then to implement those recommendations. We've tried to, like I said, be as creative where we can with training. So there's free training available for INL on their ICS Cybersecurity 301. Every one of our process control specialists have been through that training. And that's just kind of once we get somebody on board and we try to schedule, and then, those type of trainings that are available that aren't a big expense to the department, but have a really good payback. And then also, changing the way our systems are engineered to reduce risk. So there again, I mentioned a little bit about making sure that the manual operation is still available, that there's still local controls on the different critical assets that are needed to provide services, and that our engineering teams understand that that's part of the design. We're not having to go back and make modifications like we were in the past. Now that's part of the standard design. It doesn't get value engineered out. They understand that this is a need in the event that we have a network problem. So I mentioned this critical spare parts and backups, right, as being something that's really key. So that started with, us recognizing that there's certain things we need to have on hand, that, if something goes down, we need it right on the shelf, ready to go. There's other places where we do, like, all of our, we have failovers for our firewalls are active standby. We have, hot standby PLCs. So some of that stuff is, kind of a seamless failover. But if we do have components that fail, and then we have on-call staff that gets dispatched out to respond to these alarms on the SCADA system, that they know where the critical spare parts are located, right? For those assets, they have those. And that was quite a process to go through and identify, just cataloging all the assets that we had, and then identifying what parts were needed and what parts are long lead items, right, that we need to order in advance, or if we need to have a contract with a different vendor that maybe we haven't dealt with in a while, that those things are in place and those parts are on the shelf prior to us needing them, and then being, in a kind of a scramble mode. I think it was, the um, chaos monkey, I think, was what was mentioned earlier today. But we want to avoid as much as we can the chaos, and just bring some, a planned response that everybody knows where the parts are and how to get them. So also developing system hierarchy for prioritization of those assets, that we could help with that cataloging. And I mentioned the long lead items. Also developing working relationships with our neighboring agencies. So we have a lot of, neighboring agencies that we communicate with on cybersecurity. We do quarterly meetings as far as, different challenges that they're seeing, or different training that they may be aware of, or they may host, or vice versa. Our facility, we're able to host other agencies at times, and we'll cost share if it's something that we have to go out and spend, funds to get a RFP in place and select a contractor. But we try to share as much as we can on the information, but also, if there's parts, there's been, in different storm events, right, where we'll have an agency that lost a circuit breaker or lost a, a PLC board. And if we have that, then we're able to, loan that out. And there's already an understanding that, they're just going to replace that spare for us as soon as they have one. Let's see. So our lessons learned. So the big part too is being able to communicate to the executives and the decision makers, so that they understand, how these, these improvements that we need or are identified, where we need to spend money, that how that's aligned with our strategic plan for the department. And so that goes, a long ways for helping that they have goals that they're trying to achieve. And then if our goals for, maintaining the system and operating the system and being resilient in line with their goals. Because it's always, when it comes down to it, right, we definitely need to be there. That's kind of what we sell is trust, right, to the public. And that when they turn on the faucet, that they're going to get clean, safe drinking water, and when they flush, it goes away, and that their homes are not going to be flooded. But I think, a lot of times it's important to go through the steps with our executive team so that they're able to see, the importance of these improvements or making a change. And one of the things where I seen was a big benefit to us is we were able to partner with the consulting firm that helped us develop a master plan, and we laid out, a project for updating all our obsolete hardware. There was a number of components that had been, run to failure was kind of the mode in the past. And so we started updating, and we would bring, these concerns up at different budget cycles. But I noticed that once that we were able to partner with the firm that we used was West Yost, then we were able, to get some attention, right? Because now there's this third party that's also helped lay out this plan and identify these, needs. And so that's a lot harder for people to just, when somebody else is pointing out the risks, that, you're going to get some traction, and hopefully, that there may be some other projects that have to get deferred or shifted, but it's all about limiting the risk, right, to the department. So which is the priority, and if you have folks that can help you communicate that priority and how that you're going to deliver within that budget cycle, then it makes a big difference. Developing and training staff, I mentioned the operating procedures and the incident response plans, and those are another thing that's key. Not that we just have the plans, but that those are exercised and people are trained on them. Because you always find, every time that we've developed a plan and then we go and, exercise the plan, there's, oh, well, this person doesn't work here anymore, or whoever used to be our contact downtown is promoted or moved on to somewhere else. So updating and reviewing those is really critical, because you don't want to find out, right, in the midst of a situation where everything is going sideways, that you no longer have the contact you need to support you. And the clear communication channels, between stakeholders to reduce confusion and speed up our actions. One of the things that we've deployed, and kind of it's been a culture shift for us, is that we train all our staff on the incident management system. So, I think there's even one of the groups, they call it ICS for ICS. So you have Incident Command System for your industrial control system. But we've started doing that prior to that catchy little phrase coming out, and it's just a good practice. And we do a lot of storm response and other emergency response, but that's a scalable program. There's a ton of information available. As far as writing procedures or writing response plans, a good place I've found to start is just start going through the ICS forms from FEMA. And there's org charts in there, there's action plans in there, and that kind of helps you go through the org chart, and then you start identifying who the stakeholders are, who's responsible for which part of the plan. So those are really key things for us that were culture advancements of us training all our staff on the FEMA training. It's available online for the most part, no cost. The forms are available online. And, we had a situation where we were upgrading some key components of our network. So after I mentioned we had this flat network, and so we went to, you know, revamped our network architecture. We had, put some new routing equipment on old fiber that hadn't been cleaned for a while. And with the routing protocol that we were using, it was, the fiber was too dirty for it, that to operate correctly. So it created a bunch of broadcast storms. It was a challenge in that area of the network. So we, deployed the incident command and had a communications plan. We put people in key locations that they were able to operate while we took the network down. And so we used our trunk radio system, which we have our own Motorola system. That's a backup. Another thing I like to do is day without cell phones. Anything we can do to kind of disrupt folks out of their day-to-day routine to get them to think, what are they going to do if they don't have this system to rely on? But we used the Motorola system, and we were operating our distribution system for about 3 hours, with folks in locations where they were with the master PLC, but over radio, our distribution folks were communicating to them. And it kind of, brought some calm to the situation. There was a plan before we, started into this work on the network. Everybody knew their role, and it was like I said, done within by noon, and we were back on the network, and everybody went home and could sleep that night. But working through those problems, that was kind of a real world exercise. But there's always ways we can, try to come up with different scenarios that are going to challenge our staff. And so, yeah, we always try to practice, good cyber hygiene, with all the normal stuff of the strong passwords, multi-factor authentication, keep our software updated with we don't do Patch Tuesday, but we review when the patches come out. If it's something that's a benefit, right, then we're going to get on that and make it a priority. But we don't just patch to patch. Because in our OT world, that's not always the best practice. So we try to make sure that we're staying on top of it, and as needed. Same thing with updates that come out from our vendors on the HMI or PLCs. We'll read the change sets. If there's not a huge benefit, then we're going to continue to operate, because what we found in the past is they might do an update not considering the legacy tags that we have in our system, and then we introduce a problem that we didn't have before. So those are conversations that we have with those vendors also. So that's another working relationship that we always try to have good communications on, and that we're the folks that are supporting us are understanding our needs and how things that they do affect our system. So, oops. But we did realize that, with as much as we've worked with our engineering group and developed standards, and that, that culture it's not, always considering, cybersecurity with the folks that are still coming along and then, trying to get up to what we're doing, and their projects have other concerns. So we're just continually reviewing our standards and specs, for those gaps that we're going to find where there isn't a CIE consideration. And then we just evaluate them case by case. We have folks that are reviewing submittals that are embedded to our larger projects. And then what we'll have to do is, we pull that resource aside, and then it becomes part of the funding for that capital improvement project. And then we have to backfill to perform the maintenance tasks with a non-budgeted position. That is, the project's paying for the original veteran person, that has all these concepts and can make sure that's what we're adhering to. But then the more routine maintenance stuff, we can have somebody fill in for them. And that's kind of how we've bridged that gap. Um, and then the design guides, as far as what goes out to our developers, that's another area that we're constantly trying to get improvement. And as technology comes along, make sure that, there's considerations there. But that we're also not introducing new vulnerabilities or a known vulnerability into a new system. Whoops. My mouse is a little touchy. Sorry about that. But these are some of the resources that I've been able to have support from InfraGard, kind of right in the center there. It's the FBI organization, but they work with asset owners to have mainly communication on situations that are going on. But I would encourage different asset owners to get involved in InfraGard. There's a lot of resources, a lot of information sharing. That's kind of how we became aware of the prior to CISA, right? The evaluations that were done by DHS. And then there's been great other partners that we've been introduced through InfraGard. Also Water ISAC, American Water Works Association. Our team has been able to provide asset owner perspective on two of the updates for the cybersecurity assessment tool. And that was a great learning opportunity for us to, learn on our side, but also provide some of the information that we've gained going through this process. And, as a major municipal utility, there's a lot of things that we see, and then also covering the 3 different systems, right? It's pretty unique. And as I mentioned, our combined system, it's one of 4 large combined systems on the West Coast. So there's some intricacies that we have in our system that we've learned lessons on, and we're always happy to share that information with folks that are, seeing some of the same challenges. But we, use the NIST standards for our, as we were developing our architecture, and then, also SANS is a great resource. There's lots of templates for policies. There's lots of white papers that are available to help, for different subjects related to cybersecurity. And I have some links here of just some of the different partners and resources that we've been able to benefit from. And then last questions.
Thank you so much, Charlie Ginger. Why don't you take on the questions?
I had a ton of questions, Charlie. Thank you so much for this. It is great to look at what happens in utilities. First, I am always inspired by the thing that I learned from you, that what water utilities sell isn't just water, it's trust. And acknowledging that the product is water wrapped in trust is crucial to understanding how security works. How has that idea infused what you're doing in Sacramento?
Well, the worst thing, right, that could happen is that we're going to, flood someone, or worse, get somebody sick. And, we don't want to be having any type of, health situation arise. And so I think that is really key, right, of being able to be informed and communicate that to our executive team that, hey, this risk could result in this consequence, right? And so, nobody wants to be the one on the news, right, explaining why we have a bad situation. And so I think, that trust has to also be there within the organization, right? That, what we're communicating to our decision makers is something that they can rely on, and we can back it up, right? And so we do a ton of tours, right? So if you're ever in town, hit us up. I'll be happy to show you around. But one of the things that was a great learning opportunity for our electeds was we had an atmospheric river situation that was January, right, of 22, I think. And it was between 22 and 23. So that was 14 days, right, of a major storm event that we had a brand new 3 of our city council people came to our department operations center. And so, as I mentioned, the FEMA, right, the way that we practice the ICS. And so we had our operations center open with all the liaisons from police, fire. We actually have a direct line to our electric utility. And so everybody's coordinating out of that operations center. And as we have power outages or whatever the crisis is, right, we're responding with support to our field staff and what they're relaying back to us. And I think going through those type of situations is where we gain, right, a lot of trust. And so I would say to anybody, don't be afraid to invite people into that and so that they can actually see what you're dealing with, right? And it's not always pretty, right? Everything that's coming at you, but they get a feel for it, right? And that has been so huge for those different elected council members that came in right after they took office, and they just seen all of this happening, right? I have a screenshot of our index screen of all the pump stations. And so I think there's like 150 that are on that index screen. There were 99 of them without power. Because we had a major windstorm that took down we're city of trees, right? It took down over 3,000 trees. And so we can move a lot of water when we have power, but when we don't have power, right, it gets pretty dicey. And so we have 23 portable generators and then 23 stationary generators, but we just have to do a rotation, right? But sorry, I'm kind of sharing this DOC experience with you, but I think those are key opportunities, right, to develop trust with the staff, with the executives, but also with your elected decision makers that or invite them in. And then after that DOC event that I said, it went for 14 days. And so we're looking at all these different interdependencies, and everybody's worried if the generators have fuel. And at one point, somebody mentioned there's this alarm going off in the front building. And so it's like, well, we better go see what that is, right? We go up there. It's like, well, the fuel tanks for fueling all the trucks, right? We're almost out of fuel because we've been going for so many days, and nobody had been in that office at that point in time. And so it's like, now we have a different way to monitor that, and it's on somebody's radar. But there's just all of those things that you learn in those type of situations, that if you can do good hot washes, capture as much of that as you can to be able to learn from it, I think it helps, right, with that trust.
I have a question, Charlie. I know that, you're going back to those real world exercise on trunk radio system, right? That was
Oh, yeah.
very reliable, and probably you said 3 hours, for folks who are listening, or cities like you, how often one should spend time on tabletop exercises, and where do you find those resources? And I'm just curious to learn, and what could be those couple of tabletop exercises that you think in going forward, that the cities like Sacramento, they should emulate what you guys are doing, and what should be done.
Well, there's a lot of different levels that we do. It just can be like, as I mentioned, as simple as a day without cell phones, right? Because I'll see that starts to creep back, right? As to where, and I'm in a little bit of a challenge right now on trying to help some people see the value of that trunk system, because it is of cost, right, to maintain that, because we own all the towers, we own all the the equipment, and then now the handhold Motorola is over $1,000 a radio. But we do see where AT&T or whoever, not to slam AT&T, but our subscription providers have vulnerabilities as well, right? And there's outages there, and so that's where I'm not wanting to jump on like some of our other folks in our central IT, or let's just move away from the trunk system because it's expensive. But to me, we are back to that trust, right? When the the community is relying on us, we need to be able to be there for them. And so that's the, one of the simple things is just those little disruptions to get people out of their routines that can be done without a lot of cost. And just to make sure and in following through on the, standard operating procedures, and then that we go through and we evaluate people, right? That they can actually follow and perform the task. Those are things that I think often it's easy to just assume that somebody got the information they were trained on, but if we don't have a way, to go back and validate that with an assessment. And so we just have some simple little ranking sheets, right? There's certain key tasks that they need to be able to perform. Was that at level 2 or level 5, right? Those type of things. But then beyond that, there's different groups from the state, right? That we're involved with the state water resources. So there's flood exercises that we, collaborate on and have as an annual flood fight exercise that we do. And then we always try to put a SCADA element into those exercises, right? That here's this scenario. What would happen? What would happen? How would you handle this if this were to be something you're faced with? And then another one that was a huge, benefit to us is, I mentioned West Yost, but we had a day without SCADA exercise that was all the way to our executive people in attendance, right? So we had engineers, we had division managers, we had directors that were all observing this tabletop. So there was a scenario, right, that was laid out. And like I said, we tried to involve all the different crafts and all the different disciplines as they had, a role in responding to this. And that was really beneficial. And like I said, there was a lot of things that were identified there to say, hey, we no longer can do this, in manual. We no longer have local controls on these pieces of equipment. And so those were big takeaways from what I felt like was that investment, right? To have that tabletop. And it's always an investment, right? You have all the staff time, and then we had our consultant, which was just part of that cost with, when you're seeing all the staff time. But really the benefits, we still, we have those today, and staff have a confidence level that they didn't have before, right?
Thank you. Any questions on the chat, folks?
While we're waiting, I've got one. Charley, one of the exercises that we are thinking about recommending is having a team reverse through their incident response plan, kind of like you've talked about, find those hidden dependencies. And from that, develop a set of index cards so that I can walk up to a staff member any random Tuesday and say, hey, I now need you to do this. Pretend it's in the context of this exercise, but you need to get to the booster pump station. You need to check chlorination manually. Tell me how it goes. Please call me when you get there, or write down how much time it took you, but go off and do it. And the nice thing is that makes little small exercises that you could do within the scope of normal duties, not taking everything offline. What do you think of that practice, and how might that help get muscle memory in doing the things that sometimes go wrong during an emergency?
I think that's a great idea, because there again, it's not like a big expense, right? That you're having to, where you can just have this kit, I guess, if you will, right? And the different challenges be dealt to folks. And I think the big thing is that there is a way that, okay, they have a form they need to go fill out, and they need to submit, and here's what I found, and here's what here's what I was able to do, or I wasn't able to do, right? And then there's follow-up work orders that go on that if there's things that they weren't able to accomplish. But also that, really to me, it's just big that it's documented, right? That this exercise is documented. Here's the takeaways from it. And then, and to me, I come from a maintenance world, so I'm constantly big on procedures and documenting things, because if I don't have a procedure and I'm testing different assets, then I'm not really trending the device, right? Because one person's doing it this way and one person's doing it that way. So
One of my engineering friends described a very scary practice, and it was Andrew, Andrew, called value engineering. And this is where your design engineer may go away and work up a system design, and someone else who is charged by the funding person goes through and says, okay, these are all the ways that we could make this design less expensive. So instead of doing home run networking runs throughout the plant, we could use wireless, and look how much we would save. And look at all of these other things that we could do that would lessen the expense. I'm really curious how your experience with cyber-informed engineering and some of these exercises has changed how you might approach the results of a value engineering exercise.
So there again, that begins with that trust relationship you have with your C-suite, right? That your executive team has to understand, here's why we need this. And then that is put into your standards and your specifications, because if you have that there, right, and then that is potentially could be missed on the design, right? But you need people that are reviewing that. But if it makes it all the way through the design, and then it's still part of the part of the project that's being reviewed for value engineering, you need to be able to go to that standard. You need to be able to say, and then have where it's not the first time that your executive has heard of this, right? And why we need it. Because it's all those public projects, right, that are over a certain dollar amount, there's a value engineering component to that. And it's been my experience that the amount they usually value engineer out of the project is enough to cover their contract, right? That's generally how it goes. So in my experience, but I think really having that trust, right, where you've got the trust of your executive team and the decision makers, whoever those are, and that that you have standards that you refer to. I'm not just making this up, right? I don't just because this is something that I read in an article last week. Now I think it would be cool if we had this, right? No, it's our standard. It's been our standard, and we need consistency on all our projects. The biggest thing I see that it's all of the redundancy, right? We have, with critical infrastructure, there's always a need for, a certain level of redundancy on the assets, and that will really get, a hit a lot of times on the value engineering. So I think it's just being able to communicate the consequences of not having that, right? And how that changes the level of risk. And then, I think a big thing with that relationship with your decision makers is you kind of get an idea for what their appetite for risk is, right? When the working relationship you have. And so maybe you have to approach it in a way that, maybe they are a little more adventurous or whatever on certain things, but this thing over here, is important to them, right? So it's not missing any of those different elements to where I always tell people, I don't ever tell me what you think I want to hear. I'm asking your opinion because I want you to tell me what I need to know, not what I want to hear. And I feel like that's my job too, right? To those decision makers. It's my job not to tell you what you want to hear, but what you really need to know. And then if you make some other decision, right, that's your prerogative. But I've gave you all the, information to make an informed decision.
That's good. So I think, what do you think, Ginger? We can wrap it for this session here, or do you have any other questions on chat?
I didn't see anything on chat. I did have a quick one. You mentioned ICS for ICS, and that was on my bingo card. So I'm so glad you talked about that. Can you, for those who haven't been listening to Megan Sanford's every word, can you describe what ICS for ICS is and what a difference it made to have your operational technology and cyber events following the same incident command system as the other events that you service?
Sure. Yeah, so we had a culture, in a growth, I guess I would say, in our organization probably about 10 years ago to look at all the NIM SIMs. And so everybody kind of already had the basics, right? So we have, depending on what your classification is, your role is in our department, there's different levels of FEMA training that we require you to have. And so if you're in the if you're a field line staff, then there's these classes that you need to have. And then if you're in a technical role, there may be other classes you need to have. If you're in the Department Operations Center or you're in the Emergency Operations Center downtown, then you have the appropriate level of the FEMA training for the incident command system. So that was a benefit to us, kind of already having some folks with that background, right? And then, like I said, whenever we were able to, put that in our world, because I had one of the things that helped us is we, there again, try to get creative on how we can find support, but we had an annuitant. It was a retired police lieutenant. And then we also had another retired annuitant that came back. It was a retired fire captain. So I call them guns and hoses, but they were a great resource for us, right? As far as these guys, they had that background, that emergency response background. And then so I was kind of sharing with them what the woes of this network upgrade we're doing. And the lieutenant just says, "Hey, have you thought about using ICS for that?" I was like, wow, that is a great idea, right? Here's our communications plan. Here's all these different, everybody's role. And so those are things that I think, are really important for people to look at how scalable it is, because you can have a cyber incident or even just a network outage or component failures that you're dealing with stuff. And the incident command structure is so scalable, right? That you may need to pull in outside agencies, you need to pull out in consultants, and there's all the ability to scale up to that level, or it may be something that you can just do within your team, right? And then if you just go to the, I can share my slides if you would like, but those links I have on there, right, to the FEMA forms, there's like a whole booklet of forms. And then you just, whichever ones you need, you don't have to use them all, right? But whichever ones apply to your situation. And so that's a big thing, is having all our staff trained on incident command. And then, as I mentioned, being able to go to INL, to, 301, and, the different online classes that are there, that has been huge, of just getting people. Now we have everybody, we'll come back, and we were dealing with the GIS thing the other day on security, of it's wide open. We don't think it should be that way. And we have people looking at it like, who's gonna do anything with this information, right? It's like, no, you got to put your black hat on, right? You got to start thinking about, hey, what could happen, right? And so that kind of helps all of our process control people have that vigilant mindset, right? With having the knowledge and the training they've been able to gain there. And then, the ICS just kind of helps to bring some organization to the chaos, right? Of like, I don't have to be, all just chasing my tail around. There's a way that we can set this up and have a plan, and everybody knows their role in the incident, and here's how we communicate and have we're documenting it as well, right? Because like all of our flood stuff, sometimes there's FEMA money for reimbursement on those type of storm events. So that's another key thing of us being in the mode of documenting everything, because if it's not documented, then we're more likely not going to get reimbursed. And so we just try to practice that with our cyber as well.
Well, thank you, Charlie and Ginger. I appreciate you made use of all the 1 hour. I appreciate for making it work. I think we learned a lot from your presentation. Thank you so much.
Thank you. It was a privilege to be here.
Yeah. Moving on to the next session, we have Dr. Siby Plathottam from ANL and Dr. Kumarsinh Jhala, ANL. The title for this session is Adaptive Cybersecurity for Distributed Energy Assets Using Cloud-Supported Edge Devices. Do we have Dr. Siby's bio? Dr. Siby is a principal energy system scientist at ANL. He received his PhD in electrical engineering from UND. Before pursuing his PhD, he worked as a senior manager at STEAG Energy Services in India. His research interests include power system, dynamic modeling, applied machine learning, power system protection, and cybersecurity, and Harvard in the loop evaluation. He collaborates closely with universities and other national labs and OEMs. Since joining Argonne in 2018, Dr. Plathottam has been a PI on DOE projects sponsored by CSER and OE, and a team member on projects from CETO, AMO, and WPTO and BTO. He's actively involved in IEEE working groups and organizes panel sessions for IEEE conferences. Thank you, Siby, for being here. And we also have Dr. Kumar. Is Dr. Kumar is also here?
Yeah. Hi, this is Siby. Yeah, he should be joined.
Just moved him.
Yeah.
Is he joining?
Yeah, he joined.
Oh,
Great.
Dr. Kumar, thank you for being here. He's a principal energy system scientist at ANL as well. His research focused on grid reliability, DER integration, and cyber-physical resilience for critical electric infrastructure. He also leads multiple US DOE-funded projects advancing grid edge intelligence, secure DER aggregations and control, distributed system congestion management, and resilient microgrid operation under cyber and physical disturbances. Dr. Jhala collaborates closely with electric utility system operators and industry partners to ensure research innovation translate to practical deployable solution. He is an associate editor of the IEEE transaction on smart grid and contributes to standards and working groups in grid modernization and cybersecurity. He received his PhD in electrical engineering from Kansas State University. Dr. Jhala's work emphasizes bridging theory and field deployment to strengthen operational security and resilience across the nation's critical energy infrastructure. Thank you, Dr. Kumar, Dr. Siby, for being here this afternoon with us. The floor is yours.
Okay.
Right.
Thank you. I'll share the screen.
Can someone confirm that they can hear me?
Yes, we can.
Okay, perfect.
And can you see the screen?
Not yet.
Not yet.
Or maybe it's or maybe my view, or Tanzim, can you see the? It's coming. It's
how about now? Okay.
It started. Oh yes, we can see now. Yes.
Okay, great. Yeah, thank you, everybody. So Kumar is going to do half the presentation, and I'm going to do the remaining half. So Kumar, you can start.
All right. Good afternoon, everyone. And thank you for joining this Critical Infrastructure Summit. As Dr. Prakash introduced, I'm Kumar Jhala, Principal Energy System Scientist at Argonne, and I'll be co-presenting with Dr. Siby Plathottam, who is also Principal Energy System Scientist at Argonne. Big thank you to our host, University of North Dakota, Dr. Prakash Ranganathan and the team for organizing this workshop and giving us opportunity to present our work here. So our talk today is Adaptive Cybersecurity for Distributed Energy Assets using cloud-supported edge devices. In short, as DER becomes core grid resources, the perimeter is now at every inverter, gateway, and cloud API. We will show how we detect, verify, and contain attacks at the edge while managing intelligence from the cloud. With that, let's jump in. Next slide, please. So we will quickly go over multiple areas. Why DER cybersecurity now? What is the threat landscape and what is going to be its impact? We'll then talk about our solution, Intrusion Diagnostic Unit, which is a cloud plus edge device architecture. What methods and how we implemented them, including anomaly transformer, reinforcement learning plus game theory, federated learning, and then finally we'll end with some results and some conclusion. Next slide, please. So DERs are now critical resources. They talk to OEM clouds, aggregators, and utility DERMS, often over protocols like IEEE 2030.5, DNP3, Modbus. that connectivity is essential for grid services, but it expands the attack surfaces dramatically. Our position is pragmatic. Security must live on the edge device and the gateway, and not only in the control center. If a set point can be changed, it must be verified. If a telemetry can be spoofed, it must be challenged, right? And this is where we need to understand that as our attack surfaces exponentially increase with number of devices, and we cannot have these resources have their own private networks, so they're going to use public communication networks. And as we start using AI, our attackers also start using AI, so we need to get much smarter and respond to cyber attacks much faster. Next slide. So what's the risk? 4 things we care about every day: grid stability and blackout. Coordinated subtle perturbation can tip local areas into cascading events. Market manipulation. Tempered signal can distort market prices and change the generation dispatch. Asset owner disruption. Consumers are key aspect of things. Compromised fleets interrupt operations and revenue. It causes severe inconvenience to consumers. And the main challenge is AI-driven threat. Adaptive attackers learn around statistic rules. So the bottom line is availability of power, integrity of the grid, and trust of consumers can be lost in minutes if we don't act at the edge. Next slide, please. So we focus where attacks cross the control loop. So denial of service to force timeouts and disconnects, false data injection attack on telemetry or set points, man-in-the-middle attack to intercept or modify control channels, malware, ransomware on gateways, controllers, supply chain issues in firmware and libraries. So every one of these shows up somewhere between the edge, gateway, cloud, and aggregator. That's exactly where we instrument and we defend. Next slide, please. So today's stack, right? You have VPN, firewall, static IDS, log analytics. They help, but gaps still remain. So confidential attackers still look legitimate. Subtle FDIA hides inside normal variability of the system. Operators lack a safe way to challenge suspicious command. So detection alone isn't enough. We need verification and active defense that respects power system limits. Now, in addition to technical challenges, we have challenges that how currently people address these challenges. So if you have an expensive piece of infrastructure, you can develop a proprietary communication network, you can air gap the system, but that's not practical when you're dealing with thousands of edge devices. A custom solutions won't work because custom solution by definition requires you to tweak your solution a little bit for depending upon how you're installing it. If you have thousands and millions of these devices, it has to be a off-the-shelf solution. And DR gateways are there, but they cost as much as DER. So no one is going to invest $700, $1,000 on cybersecurity of an asset that cost maybe $1,000 or $2,000, right? Next slide, please. So enter the intrusion diagnostic unit, a device level capability with cloud lifecycle management. It provides real-time monitoring, detection, mitigation at the device gateway. It's a plug and play with aggregators and DERMs. It is cost-effective and scalable, as well as privacy preserving, and ultimately run at the inverter or gateway. So think of IDU as security intelligence at the edge, which is continuously maintained from the cloud. And here our goal is to have solutions at every inverter and cybersecurity card and inverter power module itself. But given the inverters don't have those capabilities, we implement it on an edge device like NVIDIA Jetson. So Our approach has three main pillars: anomaly transformer for physics-aware time series detection of false data injection attack and unsafe set points; reinforcement learning plus game theory active defense, where we inject small, safe, active and reactive power watermarks, and then test whether the system responds as physics says it should. And if not, then we can identify whether it was a false data injection attack or whether it was a man-in-the-middle attack. We use federated learning, so fleets learn from each other without sharing raw data. So together we detect, verify, and adapt with minimal operational disturbance. Next slide, please. So here's where we started. We put a small security brain at the edge. As I said, we call it Intrusion Diagnostic Unit, or IDU. The IDU sits on a low-cost edge AI device, think like NVIDIA Jetson class, and next to a bank of inverters or other DERs. One IDU can protect multiple assets behind a gateway. It watches two things in real time: what the plant is doing, so telemetry, set points, and what network is saying, control and data traffic. So locally, it runs our physics-aware anomaly transformer to spot unsafe set points and FDI, and it can perform tiny, safe PQ probe, active and reactive power probes, to verify commands when something looks off. If risk is high, it flags or contains at the edge device boundary, and if connectivity drops, it still keeps working offline, right? So, and the cloud's job is life cycle, right? Model and policy updates, fleet analytics, and integration with the aggregator or DERMS, and not necessarily streaming raw data. That design keeps costs down, preserves privacy, and scales across OEMs because we speak standards. We use standard interfaces for this project. Now, Siby will talk about how we implemented this and go from there. Thank you, Siby.
Thank you, Kumar. As Kumar mentioned, first of all, yeah, thank you again, Dr. Prakash, for joining, for inviting us, and it's a pleasure for me to be back in my alma mater to do this presentation. So as Kumar mentioned, when we originally started this project, yeah, we knew we needed to have something at the edge that will respond within a few seconds. But given the limitation of the edge an edge device, in terms of computing power and storage, we also knew that it needed to be supported. Need to have a full cloud infrastructure to support this, so that it can basically be deployed and then maintained automatically. So that was our concept, and then when we implemented that concept using the edge, different services, as well as different types of machine learning models. So in our algorithm, we have four different components, I would say, in terms of infrastructure. One is the anomaly transformer, which is basically our physics-aware anomaly detection service. So and then I'll talk more about that later. So that is deployed on the edge device. And then we have a bunch of services on the edge device that supports this transformer model, so that it can basically perform inference at up to 1 second time resolution, and give anomaly flags within that time. And then we have also for training the model, we use the HPC at Argonne here. And also we have a repository for storing trained anomaly detection models. On the cloud side, we have we started with using Amazon established Amazon services that allow us to ingest data, critical data from individual edge devices. So things like net flow data and flags from the anomaly detection model. so that these can be used by our game theory and RL agents. Also, Kumar mentioned about federated learning. So that was a key part of our project too, so that we can, we wanted to update our physics aware model, which is a transformer model with data from multiple DR sites. But to do that, we need to ensure that the data is not shared between sites. So for that, we used federated learning, and so we have a federated learning server that is deployed at the cloud, and we have a client that is on the edge device. So all this, so we'll be going through individually through each of these different components in the next few slides. So the first is the anomaly detection at the edge. So where we took a standard anomaly architecture called the anomaly transformer, and we used historical data from real DERs and also simulated DERs. So the real DERs were both from Argonne as well as from outside. Basically we took data from nearly an year at 1 second intervals and trained this model. So basically this model now understands the real patterns of a DR, of multiple DR features. So we took multiple features like for example, the DC link voltage, and also the AC power output, also the frequency, the inverter output voltage, things like that. So all this data that allows us to keep the anomaly transformer to learn an internal representation of the actual physics of the system at a very fine resolution. So whenever it sees an anomaly, it actually is we can actually generate a flag from this this anomalous behavior. And we use the basic principle behind this is using something called autoencoder, and it uses thresholds to basically classify between anomalies and non-anomalies. And our algorithm currently we are able to get around 90% FN score, which is which is basically like a mean of both the false positives and the false negatives, and that is the accuracy and the precision of the model. So this is a pretty good accuracy, and also we have used some other more advanced techniques to get up to 96% FN score. Another thing is that we didn't just do this in an offline. We have tested this using real FTIA attacks in a real-time test bed. And we also have the code for this released on GitHub. So then the next slide is on the game theory and RL-based perturbation detection. So I'll let Kumar talk about this.
Yeah. So most traditional methods of attack detection relies on observing the system and deciding whether the system is under attack or not. This is slightly different. So we are talking about active perturbation-based defense. And the idea is that using DERs, you can change the power output of P and Q set points in a pseudo-random fashion. Essentially, you are injecting a pseudo-random binary signal into the grid. When you change the power output of these DERs, it causes voltage of the distribution system to change accordingly. So essentially, we are creating a hidden perturbation signal in the voltage profile of the distribution system. Now, at other DERs, you can measure the voltage and identify whether this hidden perturbation signature is present in that or not. And if we identify that signal is present, then you have some confidence in saying that this measurement is authentic. And if you injected a perturbation signal and you do not detect it on the other side, that means the measurement you are getting on the other side is essentially compromised. So this is what we, it falls under the class of moving target detection, right? So formally, you can do this if you have knowledge of grid topology, because that allows you to know what would be the impact of changing P and Q set points on the voltage of the system. But if these are consumer-owned DERs, you don't know the grid topology. So that's where we use reinforcement learning to understand the grid topology and how the power output set points at one DER will impact change in voltage in the other DERs. So formally, we cast this as a Bayesian Stackelberg game. The defender chooses perturbation under Gaussian process belief about the attacker, and RL agent adapts the perturbation policy online to match risk while minimizing cost. Here, the cost is what is the magnitude of perturbation being injected into the grid. You don't want to inject very large perturbation in the system because it might interfere with the normal grid operation. We also establish a regret bound, so performance improves towards the optimal strategy over time. So on the right, you see the framework diagram that shows the loop, belief update, RL tune perturbation, and then you have a detector that is detecting presence of the hidden perturbation signal in the voltage. On the bottom left, you see detection performance versus baseline, and we originally tested purely using reinforcement learning, but with game theory plus reinforcement learning approach, it overperforms the RL only approach. On the bottom right, you can see perturbation magnitude. On IEEE 14 bus and 123 bus system, the training drives the probe size down to roughly an order of magnitude while maintaining the detection. So the takeaway is active defense that verifies suspicious commands with minimal disturbance, stays within inverter limits, adapts in real time, and scale to VPP fleets. Next slide, Siby. You can take over.
Okay, so the next slide is about federated learning. So this is I mentioned about the anomaly transformer in 2 slides before. So here what we are doing is we want to make sure that this anomaly transformer doesn't remain static. Like, so we train the model at using an initial set of data. We deploy the model on our edge device, but we don't want this model to remain static. So we want it to actually learn as the DR patterns change, the DR physical variables change over multiple years. So but obviously it is not feasible to, take a large amount of data and, take it back to a central server and train it and then redeploy it back, because that will create a lot of data privacy issues, and many DR asset owners or will probably be even unwilling to share data. So what we are instead do is, so we use federated learning. So we have a federated client that uses the local data that is available to that individual DR or the individual fleet of DRs that is connected to our IDU. So it will just use the local data to train a model, and then it will just send the model updates to what we call the federated server that is located in the cloud. And so the federated server will receive multiple updates from multiple different IDUs, and which each have their individual clients, and it will aggregate these model updates to create a new model. And once it has a new model, we have access to the model, and we can do further testing on the model, and then if we think it actually improves our performance, we can actually we can send the model to our repository, and then from the repository it can get deployed back onto the edge device. So so this architecture allows us to continuously improve our cyber physical anomaly detection model using transformer model, and one of the key aspects of this project, and this was pretty much entirely done by University of North Dakota. We supplied, so they were able to take our anomaly detection model and then have it deployed on the edge device, and also have the aggregation happen on the cloud. So this was our anomaly transform model was around 25 million parameters. So it was a fairly good technical challenge to actually get this training on an edge device, but we have been able to successfully do it, and also we have shown that we can do it from multiple test beds. So that is federated clients that are located in test beds that are located many hundreds of miles away. So and this was a major technical achievement for us and a key part of our project. The next slide, I want to talk a little bit about the edge services. So, sorry, the cloud services that are used to maintain the edge device. So, our main idea behind the cloud service is that it's a virtualized platform that can host services that supports the ID on the edge. So the edge service by itself, the cloud service by itself cannot work. So it is only meant to support the IDU. So and also if in a situation where the cloud is disconnected from the IDU will still work. The edge IDU will still work because the IDU doesn't need to be completely connected to the cloud at all times. So what the IDU does is it ingests some of the data that the edge device collects, like for example the network data, like net flow data. It collects alerts. So there is a Suricata intrusion detection system that is also it's a rule-based system that is also deployed on the edge device. So if it generates any network alerts, it sees based on anomalous network packets. It also sends those information to the cloud, and it also sends the flags from the anomaly transformer. So so basically the cloud is able to fuse all these multiple streams of data together, and it's able to use an attack classifier based on an RL engine to classify the exact attack, and it's also able to send decisions, take mitigative actions using a game theory engine. And we use robust inter-service communication to do this. Also, we have tested this architecture, this end-to-end architecture use from the cloud all the way to the AWS and back to the edge using the AWS cloud. But currently, we found that one of the key takeaways from this project was using AWS is kind of expensive. So at least for development purposes. So
we are running out of time, so maybe you can wrap it up in 1 minute, and then we can have Q&A.
Oh, sure. Okay. Actually, I have 2 more slides, so I'm going to quickly go over the next slide, which is a key part of it, the testbed part. So whatever service we deploy, whatever modules we develop, we tested rigorously. So we have 2 testbeds, one at Argonne and one at Iowa State University. So our testbed consists of both, the Argonne testbed consists of both real and emulated DR. So here so we simulate a real DR ecosystem, and then we have a red team node and where we inject actual attacks on both the DR as well as the DR gateway. And then we see how our intrusion diagnostic unit performs. And also how the data flow is happening from the edge device to the cloud. So for that, this is the diagram for the Argonne testbed, and we also have a different testbed ISU, but the ISU testbed is based on the OpenRT simulator. So we simulate multiple DERs in real time with the distribution system simulation. So here we are not only able to look at the device level effects of intrusions, but also look at the impact on the wider distribution system. Finally, our conclusion is that we need distributed assets, energy assets to interface with clouds, but through the existing communication infrastructure, but also that the security has to live at the device, at the very edge. Yes, with that I conclude, and both of us are open for any questions.
Thank you, Dr. Siby and Kumar, for your time. So questions for ANL team? Please put your questions in the chat, or any questions. If not, maybe I can start asking a 2-part question. How do you see resilience connection with your work? and also how this work can be extended to other critical infrastructures. What's your plan?
I can answer the second question easily regarding to the second, how it can be extended to other. So the architecture that we developed, it's kind of right now it is for DERs, but it is because we are using data from DER. So we are using the communication protocol to communicate with DERs, but it is applicable to any kind of energy asset. So all we need to do is change our communication protocol, and our device, our IDU can communicate with that, and then also we need data obviously from that particular there's some historical data from the energy asset that we want to protect. So the architecture is kind of agnostic. It's just that we applied it specifically to DER. Well, maybe Kumar can access.
So regarding resilience, right, it's a very interesting question because the DERs play a very significant role, specifically when you're talking about how they react in events of faults, or how they react when you're trying to bring the system back from a blackout, right? Whether that blackout is created by cyber attacks or any other event. This idea of using cloud backed up infrastructure that allows you to control your DR using a secondary control while you are in the blackout state. So maybe you want to restore power, but you don't want your DRs to come back online immediately, right? And these signals has to be sent to these DRs in a very secure manner. Otherwise, you will have a lot of stability issues in the power system. So I believe that this whole concept of edge device securing all thousands of DERs, how they behave in that situation, that's very important.
Thank you, Dr. Kumar and Siby. I think we are on time for the next session. I appreciate for you being here for this afternoon session. Thank you so much.
Thank you.
Let's move on to the next presentation. Dr. Ginger, maybe you can introduce the speaker.
So we are going to end today's session with a bang. And thank you all so much for spending the day with us. I'd like to introduce Andrew Ort, who is a resilience practice area lead with West Yoast, and he'll describe a little bit about what that means. Andrew was born in Duluth, Minnesota, and is the resilience practice area lead for West Yoast. Over the last 6 years, he has led the development of numerous water sector, cybersecurity, and cyber-informed engineering resources. In addition, he supports INL with the development of cyber-informed engineering resources, guidance, and best practices. Andrew's talk today is on adopting cyber-informed engineering, the Lego set you don't have to finish today. And Andrew, you had everybody here at Lego set.
Wonderful. I figured talking to a bunch of engineers that would be the case. So I'm going to share my screen. If someone could just confirm that you can hear me.
Your voice is kind of going back and forth. Let's see, hopefully.
My voice is going back and forth.
I think we had a slight bit storm, but it seems to have resolved.
Okay. Yeah, we can see your screen, Andy.
Sounds good. So, okay, great. Thank you. All right. Well, thank you for that introduction, Ginger. So a couple days ago, I was sitting in my living room wondering why there were Legos scattered all over, and it was the end of the day, and I realized that one of my sons was in the midst of putting together one of his favorite Lego sets again, and I thought, he didn't have to finish it today. That's actually a pretty good way to go through life, making a little bit of progress, and it's instructional for adopting cyber-informed engineering. So I am with West Yoast Associates. I do live in Duluth, Minnesota. I imagine that those of you at INL and at UND had a wonderful Aurora Borealis display last night and early this morning, like we did here. And it's a pleasure to be able to speak with you, I think, is the last presentation of the day. So in addition to being a water and wastewater engineering company, that works across the United States. We have the privilege of working with Ginger and team at the lab. And one of the recent projects that we've completed is exploring adoption pathways of CIE adoption. So what we have here is a pending document. It has not been published yet, but it's very, very close. And just want to take a minute and say thanks to some of the other authors here, of course, Ginger and Ben from the lab, and Sarah and Alicia from MITRE, and then my colleague Jeremy here at West Yost. And then there are a number of other people, and we'll get into some of those people as we go through this. So the presentation today is pretty much going to follow the outline of this document. So we'll go through a little bit of an introduction. I want to talk about some of the findings at a high level. We will spend probably most of the time talking about the exploration of adoption pathways. We'll briefly touch on the recommendations for follow-up activities, because of course there's always more strings to pull and things to look at and questions to ask and answer. And then we will wrap up. So let's see. So the first note on our approach is we really broke down the stakeholder types into 4 categories: asset owners, engineers, OEMs and vendors, and governance organizations. So of course, asset owners, those are the orgs that own the power lines and the generation facilities and the water treatment plants and all of the other types of facilities like that across all of the sectors. Engineers, so I am an engineer. You'll probably hear me pick on engineers every once in a while today. That's because I'm just looking in the mirror. So we are the people who help design and construct and commission all of those different assets and facilities and that sort of thing. OEMs and vendors, of course, we can't do a lot of what we do without the equipment they make, the switches, the firewalls, etc. And then governance organizations. So this would include regulators and anybody who sets standards, all of those types of organizations. We definitely didn't want to leave them out because they're starting to play a bigger and bigger role in the application and adoption of cyber-informed engineering. Do want to give a brief shout out to Idaho Department of Environmental Quality, who actually rolled cyber-informed engineering into one of the big funding mechanisms for water infrastructure for the state. And they're really, really setting the tone. It's amazing what they're doing there. So they'll actually have some CIE specific guidance coming out, I think, relatively soon for engineers and asset owners. So, right, we categorized, people that we were going to engage with into these general types. And at the end of the day, we wound up speaking with around 25 to 30 people. And you can kind of see here very briefly where these people come from, right? We are a water wastewater firm. INL is a DOE lab. So I would say half to 2/3 of the people either, are cross-sector, water, or electric. There were some people who were from the federal government who we spoke to, and then you can see some of those smaller pie charts there. And then within each one of those categories, we identified OEM and vendors, engineers, asset owners, and governance organizations. And really the point here is that we got a really wonderful cross-section of people, and the feedback that we got was just really, really exceptional. So one more slide on the approach. Before I go to that, I just want to describe that we went into each one of these interviews. I will say that some were held at conferences in a small group setting. Some were just one-on-one with me and the interviewee. But for the most part, we had a couple of team members and 1 or 2 interviewees. And we really just had a wonderful conversation, about an hour to an hour and a half each, and got a ton of feedback. We had a set of 12 questions that we came in with. I'm not going to show them all to you today. I just want to show you the top 3 from my perspective. So what I would like you to do is as we go through these, think about your reaction. So what was your initial reaction when you heard the term cyber-informed engineering for the first time? I'm asking this, and I wanted to ask people this, because I remember in 2019 when I heard the term for the first time, and I went, oh, that makes so much sense. And a couple of years later, I had the opportunity to run a CIE workshop with a client, and this was just an introductory discussion. We had maybe 15 to 20 people from their organization and a couple of the surrounding utilities. And there was this very grumpy engineer sitting in the front who, I've worked with for a long time. We know each other. And so, we got about a half hour to 45 minutes into the presentation, talking about CIE, the why and the what. And, he got this big smile on his face. And so at the break, I went over and I said, "Hey, why are you smiling all funny like that?" And he said, "You know what, Andrew, I've been trying to explain these issues to my leadership for so long. I just didn't have the words." And so this was, it's a question that I really wanted to ask people and get their reaction. And it was a lot of, "Oh, this makes so much sense," was really the theme. Number two, what are the characteristics of an organization that's ready to adopt CIE? Think about that, right? There's so many different organizations. I think we have approximately 50,000 community water systems in the United States. That's a huge range of capability and a huge range of maturity. And then of the 12 principles, where should someone start adopting CIE? And we'll get into this in a little bit. All right. So I want to touch on findings here very briefly. So that very first question, right? One of the things that we noticed is that people really explained that they had a lot of light bulb moments. And these often came kind of like what I just described. Through small groups, they're focused very much on reliability, safety, and the functionality of systems in the face of a changing threat environment. The next thing was, to really focus on or reframe CIE's benefits to organizational strategies or goals. This is a tactic as old as time, right? If your organization has a mission and a vision and a strategic plan, find those that apply and create a line of sight between CIE and those mission, critical functions, strategic plan goals, etc. Now, the last bullet, as an engineer, I feel very acutely, drive adoption through existing engineering practices. Now, engineers, of course, and operators, we have codes of ethics that we need to adhere to because we are all licensed professionals. And according to the National Society of Professional Engineers, we, in the fulfillment of our professional duties, shall hold paramount the safety, health, and welfare of the public. Now, I didn't build in any explanation of incidents and that sort of thing that have plagued the water sector in the last 5 to 7 years, but there have been plenty where, an adversary or an incident occurs, let's call it that, where someone changes the chemical dosing, either too high or too low, and enough of that, and you start to compromise potentially the safety, health, and welfare of the public. So, engineers really need to begin to internalize these concepts from cyber-informed engineering and practice them. So there was also an element here of, hey, this is just like really good business practices. So what are some of the characteristics of an organization that's ready to start adoption? Executive leadership is on board. We found some amazing organizations where the CEO had said, we're going to go do CIE. And all of the OT and the technical people and the engineers kind of looked around and said, really, we get to go and do this? And the CEO said, go. And it was, they were just having so much fun. And it became a big part of how the organization tackled cyber risk. Now, this idea of assigning the best possible CIE lead kind of emerged towards the end of some of these conversations. So we tend to think of this as an OT cyber risk issue. Now, that's good. And we have a lot of people and a lot of people in my company actually support those types of efforts. But kind of similar to other cross-organizational, cross-business unit type efforts, and CIE, but at the end of the day, has to be something like that. It's best to find somebody who is a really good communicator, who can operate across business sectors and can be a consensus builder. And, I think of in the water sector, sometimes those types of people are, emergency management or health and safety type people, right? They've built the trust with the people in the trenches and management, and, they're able to actually operate and convince people of things that need to be done. Of course, build on early wins and existing CIE practices. We've gone and talked about CIE to so many different organizations at this point, and I guarantee that everybody's already doing something right. Find that little nugget and build on it. And when it comes from engineering or operations, it's even better because you can tell the engineers and operators, hey, you're doing this thing really, really well already. and they kind of like, they're pretty proud of it and they're really pleased. It also makes the conversation a lot easier when you can praise someone, of course. Now, that last bullet, of course, you want to learn from prior change successes and, of course, failures to not emulate the latter of those two. Now, we did hear from some skeptics, very much so. And, what we heard is that early adopters of CIE were very much addressing this skepticism through some of the adoption practices that we'll talk a little bit about later, but of course, thoughtful change management. Some of the things that we kind of heard or themes that emerged were that, IT/OT cyber staff, we've got it under control. One other thing was that critical infrastructure has enough cybersecurity. We very much heard this from some of the more heavily regulated industry stakeholders. And, I feel that. But again, there's always room to improve, and pushing cyber risk management to the engineers and the operators specifically is a big evolution for a lot of organizations. That third bullet, what's the return on investment? We don't know what it is yet. And, I once, some of you may know Andy Bachman, and, he was with Idaho National Laboratory. He once told me that in the electric sector, nobody wants to be first, but everybody wants to be second, right? Somebody has to go and prove this out. I think that there's a project underway in 2026 to go and do this. I'm very excited to see that, how that shakes out. There's, of course, just we're human, right? So we suffer from things like the sunk cost fallacy, the fear of diagnosis, and of course, just a good old general resistance to change. I know that I suffer for that. That might just be something that's emerged in middle age for me. Maybe I've always been like this. I don't know. But now, when we start to think about, of the 12 principles, where should somebody actually start? And this is really teeing up that exploration of adoption pathways. So, of course, I'm an engineer. So when you ask me, I say it depends, right? So it's the perspective of the role of the person leading adoption. Where are your engineered assets, your built assets in their life cycle phase? What are your existing competencies? And then, of course, organizational context. What do you actually do, right? And that's going to some extent, drive where you start and how you move through life. All right, so let's move on and explore some of these adoption pathways. So who you are is really going to drive where you start. So each individual person is going to kind of have their own perspective. Now, what we found is that it wasn't always an organization-wide effort to go and adopt CIE. Sometimes it was very grassroots. People picked it up and they said, oh my gosh, I'm going to go and do this. Now, of course, in those cases, to some extent, they were building on the existing competencies, but that's also just a really important thing to do as discussed. Now, one of the findings in the project was we had, stakeholder types, but we really had roles that emerged within some of those stakeholder types. And you can see those listed out on the left. And then what we did in some of the conversations is we said, hey, all right, so if you're in organizational leadership, where would you start? And, we heard some different things, right? So we said a first starting CI principle, second starting CI principle, and this is reflective of all of the data and conversations that we collected. Now, of course, this is a very cyber-informed engineering-centric conference today and tomorrow. Consequence-focused design is the first principle. I like to say it's the first among equals because it's so important. We had 5 of those types of those roles said, hey, we're going to start with consequence-focused design. Either it'll be first or it'll be second. Makes perfect sense, right? One of the best stories, though, that we heard was that there was a gentleman, and he's really an OT network expert. His job was to go into facilities owned by Fortune 50 type companies and really, drive improved cybersecurity. He knew of CIE and he said, okay, what can I do within my span of control to help my my asset owners actually go and adopt CIE? What he decided is that within his span of control, digital asset awareness, and secure information architecture. Now, I will be honest, when he talked about these sorts of things, I viewed it with a certain amount of skepticism because as an engineer, I tend to go consequence-focused design, engineered controls, and, just start from that perspective because that's where I come from in life. But when I expressed some concern that he wasn't thinking about consequence-focused design first, he said, from my perspective, I'm never going to get the big decision makers and the business people to sit down and really talk about the consequences to their business from a cyber attack. That's just not my role. But my role is make sure all of the asset owners know what they have and make sure those are protected and the architecture is solid. And I said back and I said, that's fantastic, right? All in all, that's a really wonderful message. So don't be afraid to pick it up and start where you can. All right, of course, where are your assets in their life cycle? Are you building something or are you operating and maintaining something? Most organizations are probably doing both, which is great. It creates a lot of different opportunities. Now, many of you, I'm sure, have seen the systems engineering lifecycle. One of the things that we did as a team is we really recognized that the feedback from all of these early adopters said, hey, what we're going to do first really depends on if our assets or systems are in their pre-deployment phase or their post-deployment phase. And you can see here that the handoff is really, a commissioning, testing, validation, verification, deployment, right, to O&M. Right, so it's in place. The operators are doing their thing, and the engineers largely kind of move on at that phase. So where you are really is going to drive where you start. So if you're in that say greenfield type situation, or you're in the process of building replacement or designing replacement assets, you have an opportunity to kind of reset some of the organizational culture around cyber-informed engineering. I actually recently saw a strategic plan from a larger utility, and one of the things that they had done in this cybersecurity strategic plan is they hadn't really recognized the engineers and operators as stakeholders in the cybersecurity of the organization outside of users of the IT system. And so some of the feedback that I gave was like, hey, you have an opportunity to drive cultural change through the strategic planning process. Go ahead and do that. Now, of course, that's great if you're building new assets, but for the most part, we're operating existing assets. So what do? You get together with the operators and you say, you're having a cyber attack. What are you going to do about it? Hopefully many of you participated in the panel discussion immediately preceding this, by about an hour. Charley Cunningham from the city of Sacramento is a wonderful long-term client, and we have done some of those active defense and planned resilience type projects with him to help make sure that the operations staff were ready to go. And I have to say, they had so much fun and they did such a fantastic job. I'll come back to that towards the end of the presentation today. Now, of course, where you are in pre-deployment and where you are in post-deployment, it's going to shift whatever your priorities are. There's a lot of information on this slide. Don't worry about it. But generally what we heard is that if you're in pre-deployment, active defense, probably not going to be a high priority. And if you're in post-deployment, design simplification is going to be tough, especially if you have, say, a brand new water treatment plant that was commissioned 2 years ago. Well, I'm not probably going to be real successful if I come in there and I say redesign it and simplify it. They've already spent $200 million on the facility. So I have to start and be very pragmatic, because honestly, at least in the water sector, and I bet in a lot of other places, pragmatism really rules the day. All right, let's move in to wrapping up here. Now, I mentioned this a little bit earlier. This idea of building on existing competencies is super important. So there's a couple of examples here, and the related CIE principle. Now, this first one is near and dear to my heart. It's probably one of the clearest examples in the water sector of an engineered control. You're using electromechanical relays that can protect equipment from misuse or intentional misuse. The next one, right, creating redundancies for power communications, data centers, all of those sorts of things. In the water sector, after all of the wildfire issues and power issues in California, the level of backup power investment has been really, really substantial over the last 5 years. Creating that digital asset inventory, right? That's something that I will say is relatively uneven across our sector, but people are really endeavoring to do it. Tends to be one of those type of consensus cybersecurity practices that are coming out of all the three-letter organizations and standard setting organizations. Then lastly, making sure an OEM or vendor has those US supply chains is also really important to maintain those supply chain controls. So really what we observed is a redefinition of expectations. And I used to present this as sort of a hopeful statement, and it certainly is still that. However, what we observed is that people are out there, they're doing cyber-informed engineering. It's really kind of taking on a life of its own. And it's really a very exciting time because, to kind of come back to those aha moments, right? This is where we actually get an opportunity to really engineer out that cyber risk, bake in that risk management instead of bolt it on. All right, one of the recommendations or follow-in activities was something that Ginger and I and a number of other people are working on. It's called the Cyber-Informed Engineering Capability Maturity Model. So we're really helping to define some CMM levels, and then we're going to build some case studies and say, hey, these are some organizations, this is what they did, this is how it worked, and really learn from all of those early adopters that we had an opportunity to interview. One of the other big projects I've been working on is a book called Resilience Through Cyber-Informed Engineering. It has been published through the American Waterworks Association, or AWWA. You can see the vanity link down there. And, it's been really fun to hear from the editor that people are picking this up. We get all sorts of random inquiries from utilities around the country now saying, oh my gosh, I've been talking about this for so long, thank you. And really the intent is that it is very practical, it's very approachable. We want the reader to be able to pick it up and say, oh my gosh, I have one of those. This book is for me and it can help me. And so far I'd say we've been pretty successful. Please go check it out, order a copy. And with that, I'm about at time, and I am happy to take any questions that you have. Thank you.
Thank you. I've got my eye on the chat, so I'm hoping that the folks who are still with us have questions for Andrew, but I've got a couple to get us started. One question that I had for you, and I'm really asking you to help advise folks who may take the CIE training tomorrow. That is a workshop, and we go broadly across the surface of cyber-informed engineering, and it can be overwhelming. If there was any piece of advice that you would give to folks considering this training or coming to this training, what would it be?
So, Ginger, is this based around the water booster pump station example or similar?
Indeed, it's my favorite, but we twist and contort that example through all 12 principles.
Okay. So you're going to hear about how that example applies to, all 12 principles and, so that it's really a comprehensive training. But that example was actually born out of a project that West Yost had the opportunity to work on, where a utility was dealing with some labor shortages and a really ornery booster pump station that just wouldn't cooperate, frankly, and they were spending way too much time and people hours fixing and addressing the issues at this. And they finally came and they said, hey, West Yost, we're going to hook up. I don't know, Ginger, am I giving away too much?
Go ahead and give it away. Okay. It's not a surprise.
Okay. We're going to hook up SCADA in the cloud for both monitoring and control of this. And certainly there's more than a little bit of pucker factor when you put, OT control in the cloud. So we said, okay, client, we're going to do cyber-informed engineering on this. They said, do whatever you need to. We support that. And so in the training tomorrow, you're going to hear about how to do CIE across a lot of across all of the different principles. But the reality is that can be done relatively quickly for a smaller asset. So if you're going to go and do this adoption, find something that has some pretty strict boundaries around it and go and do CIE to it. And it becomes much more consumable. I will say that when we did the project that the training is based on, it was maybe about 40 hours of people time to go and do it. And, we're pretty familiar with the principles, so we were able to kind of get in and do it. But it's not necessarily a huge lift to get started. The important thing, it's like, most things in life, just go and get started.
Thank you, Andrew. I was going to ask you about success stories as well, but you answered that one with this one.
Thank you.
Thank you for coming and being our last presentation of the day.
It's a pleasure.
It was fascinating. Thank you, Andrew. We'll look forward to again tomorrow. And thank you everyone for joining. This concludes our day 1 session. Thank you, Ginger, for all your hospitality and questions. Appreciate it.
Thank you. I wondered if there were folks who realized at the end of today, wait a minute, I want professional development units. Could you reiterate the guidance for getting that?
Yeah, so for those who have attended, the whole day today, if you need certificate of participation or if you need certificate of professional development hours, if you need PDH, you need to take a test, which we will send out after the webinar. And if you complete that assessment, then we can send out the PDH hours, but if you need a certificate of participation, we are happy to give you that after verifying who attended and those sessions. So we'll send out an email after the day 2 as well, instructions on those.
And I wanted to remind everyone, tomorrow begins at 9 a.m. Central Time, so a little bit earlier than today. And we're starting with a very strong policy talk. So moving from practice this afternoon to policy in the morning. And I hope you all can be with us bright and early.
Thank you. Thank you.